Okay, I think we're live now, so let's just, yep, we are live. So for one, hello, and thank you all for joining the geometry live stream here. I am going to start this just a few minutes early, but yeah, someone had requested that I switch it earlier to 6, but I want to do this basically as early as possible. If people need to check out the replay, they could check out the replay. But I will be doing this I'm going to aim for about 3 hours or until I get everything through. Okay, so let's just make sure here that we have everything in line. So okay, so this is me, Vincent. All right, we're in Vin Teaches Math. So welcome aboard if you are new. Nice to meet you, and if you're returning, thanks for coming back and choosing to follow me for this live stream. So people in the chat, yeah, you could just let me know that you are here. I see we got one hello so far. So hello to, yeah, I got a bunch of requests to start a little bit earlier. So I'll just kind of do open Q&A for a minute, just to say hi to people and give people a few minutes to get a head start. But I figure most people are probably at their desks right now. Yes, it will be available to watch even after the stream ends. So there will be a replay happening here. Okay, so yeah, just throwing that in. All right, cool. Yep, hello to Anna Romero. I'm Valid Vlad, Molly, hello. Nice to see everybody. So the regions that I will be doing, if you want to follow along, is I went fairly far back here. If you went back 10 years, then I'm just very impressed. But I would imagine a lot of schools would have chopped it here at somewhere August 2017 is what I decided on. Okay, so I already worked these out. But if you have general questions here, I could always just create a fresh page and answer just your question. All right, so that is what we will focus on. Right now we have 56 people in the chat. This is very exciting to, yeah. Your stream is behind. Oh no. So I'm pretty sure it's almost immediately after that it's available. So sometimes it takes a few minutes for it to upload to YouTube. There's kind of a processing timeline. So if it's not available in high def right away, it usually is available within a reasonable amount of time after. All right. So any other questions here? Otherwise, I will just kind of jump into things here because we have a lot of questions to cover. I am going to do my best to do the whole regions. The only thing I will say, and I'll just put this out there formally in the beginning, the only rules that I would say for the live stream is pretend that you're actually in class. Just be respectful to one another and me. So the chat will do our best to keep it real. I kind of set some community guidelines in place that if people try to say things that are too kind of out of taste, it'll just block them from saying it. But I will be monitoring the chat, and reminding people. But yeah, because Algebra 1, certain parts was a little, maybe a little bit much in the chat. But it's all right. I'm going to be positive here and say that we will, have a great stream here. This is the August 2017 Geometry Regents. We will be going over triangle proofs, yes, at the very end. So August 2017, it'll say it at the bottom of each page. All right, so the first question here, what we have is can people hear me fine? Let me just do a quick audio check before I really get rolling here. Is the sound okay? Am I coming in loud enough here, or is it a little bit low? Because I put on a compressor or noise gate in OBS that I want to make sure people can hear me okay. Oh, all right, so what kinds of questions should you be? I would say the biggest topic. So biggest topic. All right, here we go. So the biggest topic on the entire Regents is similarity. Okay, so similar triangles, whether it be with whether it be trigonometry, like SOHCAHTOA, but usually when you're comparing corresponding parts of similar triangles, that is one of the biggest topics on the Regents. So, all right, so everyone can hear, so then I'm just going to go full steam ahead. So here we have a two-dimensional cross-section is taken from a three-dimensional object. If this cross-section is a triangle, so there's our cross-section, what cannot be the three-dimensional object? Okay, so this one we're looking for which one cannot be. I do have a construction that I will go over for later. If it doesn't cover the one you're interested in, all I'll suggest is that you go on my channel, and I have a ton of construction videos on individual ones. Cedra, oh no, I hope you don't fail tomorrow. Just do your best. Remember, this is just a test. It doesn't really define you as a person, so just hang in there. So a cone would be good. Okay, so a cone here, if I were to draw in, so we'll change colors here. If I drew in this cross section here, oh, and just so you know, a cross section, what I think of a slice. Okay, what I imagine, anyone from New York City, so shout out to fellow, also shout out to the whole state here, because I last time I had people as far as Buffalo coming to this, but I know there's plenty of New York City people that join this. But the slice, I imagine I'm at the deli, and that this is like they're taking like a slice of meat or cheese out. So you can see here, if you had a cone, there's your triangle cross section. So a cone could give you a triangle cross section. The answer is actually going to be a cylinder, because if we look here, a cylinder is like entirely circular. And some people might say like, well, wait a minute, what if I chop this thing down the center like this? The cross section would be a rectangle like this, not a triangle. Okay, so if you start chopping it at angles, you're not going to be able to get a triangle out of this, which is why it's a cylinder. A pyramid is kind of trivial here, because a pyramid is like in the shape of a triangle. So, if I just like cut, like imagine I had the deli slicer and I just like angled it this way and I cut off a piece like this, like, in this direction here, parallel to this face, it would give me a triangle. And a rectangular prism, this is like the next best answer, because it might be hard to see how to get a triangle out of this. But if you want to get a triangle out of this, the secret is that you have to chop this thing on a diagonal. And if you chop it on a diagonal like this, you see how it's going to hit and make a triangle. So if my slicer was coming this way at, let's say, like a 45 degree angle. Okay, so 45 degree angle, I'm cutting this corner, and I look at the bottom, I would be looking at a triangle. So that's another reason why it's option 2. So cool. Yeah, the Regents are new every year, but they are very similar. Okay. The $1 million question is like, is the 6-point question going to be a triangle proof, or is it not going to be a triangle proof? So if it is a triangle proof, then like, yeah, you have to have something. And I'll talk strategy, because the triangle proof gives people a lot of stress, because they just think, oh, I have to get 6 out of 6, or I get 0 out of 6. But as someone who's graded Regents for like 10 years now, just know if you put solid work down, more than just the givens, like they will give you partial credit. So just be mindful of that. All right. Okay. So the image of triangle DEF is triangle D prime, E prime, F prime. Under which transformation will the triangles, once again, the word not be congruent? So automatically I'm thinking dilation. This one is like LOL, because if you're just like, oh, dilation, choice 3, like be careful, because the scale factor is 1. And just know that if you took 2, 3, and you dilated it by a scale factor of 1, then this would send you, like you would do 2 times 1, comma 3 times 1, which would give you the point, 2, 3. So like nothing, I'm sorry, we're scaling, the center is at 2, 3. All right, so look, either way, like let's say, like I took the point 1, 2. If I do a dilation scale factor 1, and my center is 2, 3, it's still going to send me to the point 1, 2. Like it doesn't change anything, because I'm multiplying each point by 1, and it's like not expanding it or contracting it at all. All right, but a scale factor of 3/2 centered at the origin will change things. Okay, because that's going to make it bigger. Okay, it's going to make it like 1.5 times the size. So that would take triangle, let's say DEF, and it would make like each side here, let's say like this side, it would make it 50% bigger like this, and it would do the same thing to all of them. And this would be like, let's say D prime, E prime, F prime like this. So a scale factor other than 1 will change the size. A reflection is a rigid motion. It preserves angles and distance. So this one is out. Okay, and once again, a reflection over y equals x does not change the size of the triangle. Okay, so only a dilation would change it, but the scale factor has to be any number but 1. Okay, so that's why that is out. Yeah, I started early. I had updated it in my on my end. Maybe when I pressed save. It didn't like fully calibrate and update, but somebody sent me an email requesting, a few people were like, oh, could you do it earlier? Could you do it earlier? So I wound up doing it earlier. But anyone who joins on like a little bit late, so once again, I apologize about that. You will be able to catch the whole replay. And I should still be going at 7:45. All right. So cool. All right. So here the vertices of a square. So square RSTV have, so we have the coordinates, and what is the perimeter of this square? So for this one, there's a few ways that you could do this. And let me just see which one is the culprit. I guess they're all equally annoying. All right. Well, just one thing you should be thinking about here. A square, all four sides are equal in measure. So the perimeter, like let's say one of these sides is S, the perimeter is 4 times S, whatever the side length is. So here, if you have RSTV, you just have to pick any sides that are consecutive here. Or I'm sorry, any vertices that are consecutive. Like if you have RSTV. So this is not necessarily drawn like the way it should be drawn. But let's say I want to find, all right, what is the length of RS? I could find the length of RS and then I could multiply it by 4. So one way of doing this is if you know the distance formula, it's x2 minus x1 squared plus y2 minus y1 squared. So there's your distance formula. So you could just plug in. So you take R and S, you call this x1, y1, and you call S, that point, x2, y2. And you just plug into the distance formula. So you would have we could do x2 minus x1 first. So we have negative 3 minus negative 1 squared plus y2 minus y1. And we're squaring this. So if we run this through, negative 3 minus negative 1 changes to negative 3 plus 1. But just know, if you have to, okay, there was no shame in this. Let me just get it open now. I should have had this open in the beginning. But yeah, let's just see. But honestly, this one I did without a calculator anyway. So maybe I'll just complete this, without the calculator. But if I'm doing this without a calculator, I know on the inside that's going to be negative 2, and negative 2 squared is 4, plus, and if I have negative 4 squared is 16. So one side is going to be square root 20, which means all the side lengths are square root 20. So the perimeter of this thing is just going to be 4 times the square root of 20. All right, and notice they didn't simplify the radical on the, or the radicand on the inside. So choice 3 is like where we could stop here. Okay, so yeah. Now, one other thing. Let's say you're like, oh no, I forgot. I forgot my formula. I don't know this formula. What is the distance formula? So you're at the test and you're like, oh no, I forgot this. I'm so sad. Well, what you could do is you could take R, which is at negative 1,5, and S was at negative 3. So left 3 and up 1 like this. And you could build a right triangle connecting these, because ultimately we wanted to find like what is this distance here from R to S. And what you could do is you could go horizontally this distance and you could go vertically this distance. And you see how it builds a nice right triangle. The vertical distance goes from 1 to 5, so that distance is 4. And the horizontal distance from negative 3 to negative 1 is 2. And you see you have a right triangle, and the missing side is the hypotenuse, call it C, and you would have 2 squared plus 4 squared equals C squared. So this is just Pythagorean theorem. That also gives you 20 equals C squared, which tells you that C, the length of that side, is square root 20. So that would also give you square root 20. And in this situation, once again, you're going to do this. So if you forget the formula, you're going to use the right triangle concept. Okay, so I personally have trouble memorizing formulas. So yeah, this is not a leak. Alex, LOL, but I am definitely not going to be risking my whole career just to leak a Regents to the whole crowd here. This is August 2017. Okay, so this Regents is quite old. All right, it's about 6 years old in August. All right, moving on. So now we're up to question 4, and for this one we want to know what is the measure of arc AC. So now, if we look here, we read this question, chord CD is parallel to diameter AOB. So what that tells me right away is that these arcs are congruent, because just know that parallel chords, like or parallel lines in general, intercept congruent arcs. Okay, this is for a circle. Okay, this is like an idea to know. You could prove this, but tomorrow's the test. I would just say know this. And another thing that we're told here is that AOB is a diameter. So this part of the circle is 180 degrees. So this part here, just think 180 degrees. We're told the measure of arc CD is 130 degrees like this. So what I'm imagining here, like let's say you put an X here, then you have to put an X here. This would tell you that X plus 130 has to be equal to 180. So this would give you 2X plus 130 equals 180. And now just subtract 130 on both sides. And 2X equals 50. Which tells you X equals 25. But be careful, make sure you're actually answering the question. We want the measure of arc AC, which is equal to X. So this 25 degrees is definitely good here. Choice 1 is going to be our solution. All right. Yeah, take your time. So at Light, I really like that advice. As someone who's proctored a lot of Regents also, don't try to like just be the first one out the door. Really, like you get all this time, you'd be surprised like how much you spending like an extra half hour could make all the difference. So yeah, for sure. All right. Let's see. So we have a so remember what I said before, one of the biggest topics is similarity. And here's the first go at it. So we're told here, so we have a diagram AD. So this line segment intersects BE at point C. And we're told that AB is parallel to DE. So right away, as soon as I hear that, I'm like, all right, alternate interior angles. I'm saying angle A is congruent to angle D. So we have alternate interior angles. Vertical angles are congruent. And you see these angles here formed by the intersecting lines. The angles opposite each other are congruent. They're vertical angles. And then that would mean angle B and angle E have to be the same. So the reason I'm doing this is that now when we label stuff, we have CD is equal to 6.6. And I'm going to leave the units out because it's multiple choice. And even in the free response, they are, aren't really super strict with the units. DE is 3.4 and CE is 4.2. Just know if anyone takes physics, then they are very strict with the units. So it goes from being like not strict at all to like very strict. So just be mindful of that. Okay, and then BC is 5.25. We want to know what is the length of AC. Okay, so for this one, when you're setting up your proportion, right away what's jumping out at me is that triangle ABC is similar to triangle, and I'm going to make sure I say this correct. A is the single notch, B is unlabeled, and C has the double notch. So I would say the letters in the appropriate order here. So I would say triangle D, and then the unlabeled angle here is E, and then C is going here like this. I don't know if I said F a moment ago, but it's been a long day. But triangle ABC is similar to triangle DEC. So now that I wrote the letters in the corresponding order, notice the letters are in corresponding order. Okay, that's very important because then that allows me to set up my proportions correctly. And let's say here, like I want to say, all right, AC, like I want to know what is the length of AC, like that has the X on it. AC over BC equals, in this triangle, one thing to be mindful of, A is the first letter, C is the third letter. And then BC, B is the second letter, C is the third letter. So just think first and third, I would have DC in this triangle. Over, and then we did the second letter, third letter. So second letter, third letter would be EC like this. Okay, so you see like DC over EC like this. If that doesn't make sense, then what you could do is you could look at the angles that correspond. So here, you see how AC is opposite of B? So like we would set that equal to, on this side, DC is opposite of angle E like this. So making sure that you know what corresponding means is really big. So now AC is X over BC is 5.25 equals, and now on this side, DC is equal to 6.6 over EC is 4.2. All right, now just know that DE, they told us what DE was. This is a distraction. Okay, we do not need this. Okay, we don't need to know the length here. They could have actually omitted this, and we could still answer this question. Okay, so now we're just going to go forward with this. There's a few ways to do this, but honestly, I would just multiply both sides by 5.25, like this. Okay, so multiply both sides by 5.25, because on this side, this is going to cancel, and now x equals, and now we just have to use a calculator. All right. Oh, wow, we already have 200 people joining this chat. Thank you so much for the support. I get very excited when I see these numbers because when I started out on YouTube, it took me like over a year to get 100 subscribers. Like I started out like really, like the channel was like definitely, it took a while to take off. Like I had to figure out YouTube a bit. So it's very exciting to see like how far the channel has come, like from compared to where it was. So thank you all. I really do appreciate, you know, the support big time. Like it's truly been great, like being a part of this ride. So shout out to everybody. My goal, if you have not subscribed yet, please consider subscribing. Because my goal is, I don't know. I just always want to like just keep reaching more and more people. And, you know, the more of you that subscribe, then, you know, the more this channel will reach people. Okay. So yeah, just looking here, we've had quite a bit, today. So, all right, continuing on here. So 8.25. So 8.25 here is going to correspond to choice 4. Okay, so 8.25 is choice 4. Alrighty. So that is the similar triangles question. But once again, like let's say I put a triple notch here. Like one thing, I look opposite of the angles here. So once again, like when you look at x in our proportion, like x is opposite of angle B. And that's the one with 3 notches. And opposite here is 6.6. That's why you see how 6.6 is on top. 5.25 is opposite of the single notch. And then the single notch here points to the side that's 4.2 units long. So that's how, once again, I know how to set this up properly. Because that's a skill that takes a little bit of time to be awesome at. All right, moving on here. So let's take a look. Question 6. So for question 6, we have... Let's see. I was on a different page for a second. Okay, so we have a quadrilateral. It's a rectangle. It's graphed here. Which transformation would not? Wow, this is the third time they said would not. So be on the lookout for the word not tomorrow. Don't find the one that will. So which one will not map the rectangle onto itself? That means when you do the transformation, it's going to be like in the same exact location, the same exact size. So here, a reflection over the x-axis. Well, one thing that jumps out at me, the reason why choice 1 works is if you were to reflect this over this line here, the rectangle, notice this distance is 1, 2, 3, 4, 5. So it goes up 5. It also goes down 1, 2, 3, 4, 5. So this is like the same distance above the x-axis as this is below the x-axis. So this one would work. So that's why this one is fine. The line x equals 4, let's see if that goes right down the middle. So a reflection over the line x equals 4. This is 1, 2, 3, 4. Notice this is the line x equals 4. And this cuts it straight down vertically. So this is like a vertical line of symmetry, the line x equals 4. And that would also map it onto itself. Okay, now for this part, I'm going to erase now. I probably should have gave myself, let me just see, do I have an extra copy of this Regents that I could just, oh yes, let me just go to question 6 over here. I'm going to show you, well, actually, I don't even have to erase this. I'm just going to take this, do a screenshot. Okay, let's say I take this and I rotate it 180 degrees. About the origin means turn this thing upside down. Can you see how this is clearly not in the same location as where it started? Like this rectangle is in quadrants 1 and 4. Okay, so this is quadrant 1, 2, 3, and then 4 here. But if you look, when we flip the graph upside down, I'm sorry, the rectangle. I don't know if I said triangle. The rectangle is now in quadrants 2 and 3. So this would be the one that doesn't map it onto itself. Okay, that one is out. So yeah, that's like how I'm thinking about this. I just made space because the question was getting chopped. But let's think about, why does this one work? A rotation of 180 degrees is about the point 40. Well, you see how like 40 is exactly in the middle of this rectangle. So if I were to take a picture of like just the rectangle, so now I'm focusing on like just this piece. Okay, so let me just get this in the mix here. And so let's line this up a little bit better. Just so I want to make sure you really get the concept. And I rotate this about the center. This is just going to take this and rotate it this way. And you could see it's going to fall exactly on top of itself. Okay, so in this case, it's like we're, once again, I might have selected the wrong, let me try that again. So here, and if I rotate this 180, it might be resizing it as I'm doing it. That could be why. Oh no, it's freaking out. Okay, but it lands exactly on top of itself. Like that's the concept as to why choice 4 works, which we want the one that does not work. Okay, and choice 3 would put this rectangle all the way in quadrants 2 and 3. All right, so I hope that made sense. So yeah. Yeah, if you look, so at Ella, I imagine it in my head, turn your paper. I am 100% on board with turning your paper. When I taught, I didn't even teach geometry this year. I started teaching it and then my program changed. I taught calculus BC and I taught pre-calculus. So those of you going on to like pre-calculus, AP calculus, if you want help, later, I'll still be here for you, for the rest of high school if, you want the help. But just know that, what's it called? Yeah, I'm more of a visual person and I don't believe in memorizing formulas. Like if you could understand the formulas, that is a way better way to approach math. So yeah, just floating that out there. All right, question 7. What we have here, let's see. So triangle ACD, and this is once again, proportions in similar triangles. I said that's the biggest topic on the Regents. So what were we told? All right, so here it is. BE is parallel to CD. And this is the side splitter theorem. It's okay if you don't know the terminology for this. Like, oh no, what's the side splitter theorem? If you didn't learn it like that, I'm going to show you how to get it anyway. They want us to find what is the length of AE to the nearest tenth. Okay, so this piece we'll call X. Now, one thing to be mindful of here is when we're doing this, these two lines are parallel tells us that these two triangles are similar. Triangle ABE is similar to triangle, and let me make sure I write it in corresponding order. So ABE, I'm going like up, left, right. So we're going up is A, and then the big triangle, this lower left is C, and then this is D. Okay, so these two triangles here are going to be similar. And what I recommend you do, if you can't memorize theorems, is separate them. Draw them separately. We have ABE is, AB is 1 and AE is X. And then the big triangle looks like this. The only thing you have to be able to do here, though, this is where it might get a little bit annoying, is you have to say, all right, AC, I have to do 3.5 plus 1. So if you just did 3.5 plus 1, that's going to give you 4.5. Okay, so in the big triangle, the entire distance is 4.5, and this entire distance is 18. Okay, so we're just making sure that we have this in line here. And we want to know what is the length of AE to the nearest tenth. So for this one, you could do right side over left side. So do X over 1 equals right side over left side, 18 over 4.5. And for this, X divided by 1 is just X. And 18 divided by 4.5, you could use a calculator or just know how to do this in your head. And that's going to tell you that AE or X is equal to, it's going to be equal to 4. So choice 4 like this. All right, nearest tenth is like LOL. They just threw you off. Like, oh no, it should be something other than 0.0, but yeah, this works. So me personally, like you could use this, but I like to draw the triangles separately. Okay. Hope I spelled that right, but this is not the English Regents. It is the math Regents. All right, cool. Make a proportion. Yeah, so if you are good at proportions, then like awesome. That is, once again, one of the biggest topics on this Regents is similarity. Okay, proportions of similar triangles is a huge idea. Okay, so just be great at it. All right, let's see. We're on question 8. So these I do by brute force. When I say brute force, the Regents is August 2017. Oh, thank you, Chicken Soup and Sage and everyone else who's answering that question for me. I should wear a sign on my shirt that says August 2017 or a piece of paper on my forehead. Ideas for next year. Okay, in the diagram below of this parallelogram rock, I should have had a picture of Dwayne The Rock Johnson up, but also ideas for different years. The measure of angle C is 70 degrees. And ROS is 65. What is the measure of angle KSO? So we want this angle here. All right. For this, just know in parallelograms, opposite angles. So opposite angles are congruent. So if this is 70, this is also 70. This is massive. The sum of the interior angles of any triangle is 180 degrees. So here I would take 70 and 65 and add them. And that would give me 135. And then I would subtract that from 180, which would give me 45. That is the measure of this angle over here. Okay, you could use the exterior angles theorem. Okay, like if you just know every single theorem there is in geometry, then just do 70 plus 65 is 135, and like your answer is going to be choice 4. All right, otherwise you say, oh, I have a straight line, and on a straight line, the measure of a straight line is 180. So let's say you call this x, that would tell you that x plus 45 would have to equal 180. So then just subtract 45. All right, so this is a good question because it has a lot of concepts mixed into one. All right, but the good thing about math is if you forget the theorem, there's like ways of figuring it out anyway. That's why I write brute force, because you could do this by brute force. Cool. So choice 4. Moving on. Once again, anybody who just joined, thank you for hopping on. I really do appreciate all the support here. So thank you for joining, and good luck to everybody tomorrow. I hope you all do well. I was thinking, so people could answer this in the chat. If I were to do like a last day of school stream where people talk about their regions, like the algebra, geometry, algebra 2 people, would that be something people are interested in? Yes, I am going to do a live stream for algebra 2. But would people appreciate having a space to talk about their Regents grades, like once you all get your Regents grades back? I was thinking like either the last day of school or like the day after. I don't know. Just an idea. It would be very short, though. It would be like 30 minutes long, not the full. Trig questions are coming up. So let me know in the chat if that's something that sounds interesting. Otherwise, I will just keep rolling. Okay. So let's see. We have angle GRS is congruent to angle ART, which they marked it for us. You see, they marked it over here. So that was polite. We have GR equals 36, SR equals 45, AR is equal to 15, and RT is equal to 18. All right, which triangle similarity statement is correct? So looking at this right away, what needs to happen for these triangles to be similar, that would mean the corresponding sides have to be in proportion. So we would need 36 over 45 to be equal to 15 over 18. Because you see how this is like the long side over the short side would have to be equal. I'm sorry, so this is like the shorter side. This is the long side. This is the short because it's 15 versus 18. So the short over the long side in this triangle would have to be equal to the short side over the long side in this triangle if these were similar triangles. Okay, so we investigate this. And if you reduce this, divide the top and bottom by 9. So just do this. Or also we have a calculator. Like let's say you don't know that this is 4/5. Okay, you have a calculator. All right, this thing is magic. 36 over 45, and it's 0.8. Okay, and then 15 over 18. If you want a fraction, press math, enter, enter. And then you could also do 15 over 18. 15 over 18, math, enter, enter is not 0.8. Okay, it's going to be 5/6. So here, like you investigate this, these are not equal fractions. Like divide this by 3 and divide this by 3, and you get 5/6. These are not equal. And since they're not equal, that means these are not similar. So choice 4 would be it. Okay, so you see how all of these answer choices say, oh, they're similar, 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 but no. Sometimes side angle side similarity would be nice if this were, let's think of a situation where this would work. If it was, let's see, 4 times like, let's say it was, I'm trying to think. Oh, let's say it was instead like 16 over, would this work? Over 20. I think that would work because 16 over 20, if you divide it by 4 over 4, then it would be 4/5. And like then this question would work out. Okay, but that wasn't the case. So we could forget about that and just say, yeah, it's choice 4. Okay, cool. Cool. So now just know if you're like, oh no, for any of these questions, you don't have to get every question correct to do well. Like if you're, oh yeah, the Regents I'm doing has 2 proofs. So yeah. All right, so Sage, do you think we will need to bring materials? You should know from your teachers ahead of time if they're going to let you borrow stuff. But the general rule is if they're going to let you borrow something, like it might be like the worst quality compass there is. Okay. So like that's the one thing you have to go into this expecting is that if they give you the free one, like it might be nice. Like you might know your teacher and be like, oh, wow, these compasses are like the best. Or they could just be absolute trash. Like I know some of the ones I lent out like were falling apart and kids could not make a perfect circle. So in that case, I would say bring your own. They do provide it for you once again, but it may not be the best. Like it depends on your school and what budget the school has. Like I know some of the ones we've had have been like garbage, but for the most part, like teachers will be forgiving when they're grading it. If you don't make like the most perfect drawing, like as long as the marks are fairly accurate, like you'll get credit. Okay. So yeah, we're not looking to like have anyone get a bad score. We like it when you all do well. So the line represented by this equation, okay, so there's our equation, is transformed by, all right, here we go, dilation centered at the origin. What linear equation could represent its image? So just know when you dilate a line, so dilate a line, okay, so this is some things to be on the lookout for. The image is parallel, so the image is parallel to the original, okay? And my best advice is to dilate the y-intercept because that just makes it so easy, okay? Because the fact that the image is parallel to the original tells you that the lines have the same slope, okay? So same slope. So looking at this, 4y equals 3x plus 7. Right away, I look at this and say, all right, divide everything by 4. And y equals 3/4 x plus 7 over 4. But in this case, they don't actually want us to follow a specific dilation. They want to know which one could represent its image. So we just need to have the same slope. So we need the same slope. So our line needs to have a slope of 3 over 4. And it needs to have a different, so we need a different y-intercept. Okay, so this is the idea. All right, this is what you should be thinking about. But now looking at this, if I rearrange stuff a little bit, I'm looking at this because this is like a non-conventional question. This is now testing you on like also like we need algebra. Okay, like you have to be skilled at algebra for a question like this because I could scan through the answer choices and say, all right, which one is going to give me a slope of 3/4? Like you could just solve everything for y. So solve everything for y. So can you do 2 steps of algebra in your head? And if you can do that, like you are in business here. If you can't do that, then like, oh no, it's trouble. And right away I see like, all right, it's going to be this one. Because if I took 3x minus 4y equals 9, what I'm imagining is I add 4y to both sides. So I'm going plus 4y. So plus 4y gives me 3x equals 4y plus 9. I go minus 9 on both sides. And now I divide everything by 4. And you see how here our slope is 3/4. We need a slope of 3/4. So like this is the one. Okay. The reason why this one is no good is if you solved it for y, you'd have like 4y equals negative 3x plus 9. And then you divide everything by 4. And you see how your slope would be. So for this one, our slope would be negative 3/4, which is no good. We need a slope of 3/4, not negative 3/4. Okay. And then this one, I could already see, like if I do the algebra in my head, I'm like, all right, 3y equals 4x minus 9. And then y equals 4/3 x. And if I divide this by 3, I also get like a minus 3 here. So I'm like, oh, the slope here is 4/3. And so now it's the reciprocal. This is flipped. And if we solve this one, it would give us 3y. So this one here would give us 3y equals negative 4x plus 9. And y would be negative 4/3 x plus 3 if you divide everything by 3. So this one would actually be perpendicular, not parallel. So in either case, though, 10 is going to be choice 1. All right, so this is, something to look out for. It depends on the regents, like what is passing and what's not passing. If I look at this one, so let me pull up the old regents exams, August 2017, unless somebody already, beat me to it. So let me get towards the end here. Oh, this is actually like the last page. I should have just typed in 126, but whatever. So I am on, yeah, for this one, I'll just put a screenshot of the rubric, not the rubric, the scoring criteria. And this is actually pretty terrible. Let me just, here we go. So for this one, if you wanted to get a 65, you needed, no, that's the 65 raw score is an 83. 65 would have been 33 questions correct. I'm sorry, 33 raw score, which would be between 16 and 17 questions correct in the multiple choice. All right, so that was this year. It changes year to year. Like some years they make it, I don't know if they've gotten more lenient lately, but I know, like I say, oh, don't worry about passing. Just focus on learning as much geometry as you can and working as hard as you can during the test to put down your best math on the paper. And then the rest is just up to chance. Okay, like if you start getting in your head like, oh no, I need this many questions right. I already got this one wrong. I got this one wrong. It's just going to make life, tough for you. So just focus on like doing your best. Yeah, I would look at the more recent one. Look at like June 2022 for a better idea. Or January. January 2023 even. All right, so here what we have is triangle ABC. This is 62 degrees, and side AC is extended to point D as shown. What value of x, so what's the value of x that would make AB congruent to CB? All right, so what this is telling me is we're using the Isosceles triangle theorem. When you have two congruent sides in your triangle, the angles opposite are also congruent. So, I mean, x is already taken. That's sad. So let's say I call this y. This would tell me now that y plus 62 equals 180. So now I just have to solve for y. So I have this. There's no y plus y is 2y equals, and then 180 minus 62, that would give me 118, and then divide both sides by 2, and y would be equal to 59. Okay, now this is LOL. All right, don't just go, oh, yay, 59. Think carefully here. Y is equal to 59. Okay, so this is equal to 59. So we could say here we have a straight line. So x plus 59 is equal to 180. Now we have to solve for x. So there was actually one more thing we had to do. All right, so don't get like too ahead of yourself and rush. Take your time. Like don't be on edge the whole test, but like don't rush. Like if you're like, hey, I'm the fastest test taker in the world, I'm the greatest. Slow it down a bit because you'll step in like a dangerous bear trap. All right, so just be careful. All right, this is like, yeah, truly a tragedy. Okay, please don't pick this. There is like a memorial to the students that picked choice one because you know your stuff, but you just weren't careful. Okay, silly mistakes. I agree. Yeah. So let's see. Moving on. So now we have a circle. And the tangent T is, PA is tangent to circle T. So this is the tangent line here. That means it's touching at one location. And if I were to connect this, this would form a right angle. Okay, so this would be 90 degrees, but they're not necessarily asking for that, so I won't draw it in just yet. So we have this secant PBC, where point B is on circle T, and so is point C. So, all right, here we go. This is the useful stuff. PB is equal to 3. BC is equal to 15. And we want to know what is the length of PA, call it X. So this one, I got to give a shout out to one of my coworkers. She's the first one that ever told me this rule here. Oh, thank you, Janet, $10. Wow. Thank you so much. Is that a pair too? Thank you. How generous. I just can't get over that pair. Like, what a nice emoji. All right. Thank you so much. So looking at this here, so let's see. So the wee rule, I know it's just fun to say. You'll never forget it because it just sounds funny. So the whole exterior. Okay, so the whole times the exterior equals the whole times the exterior. So like, let's say I had like two secants like this. Like if you call it like A, B, C, D, E like this. Then the whole segment would be AC. the exterior part is the part outside the circle is BC, would be equal to the whole thing for this secant would be CE times DC like this. Okay, so that's the idea. But let's say, oh no, what if it's a tangent? Then the whole and the exterior are the same thing. So here you could see that the entire segment for the secant, 15 plus 3 is 18. So I would have 18 times the exterior part is 3 equals the whole segment here is x, and the part outside the circle is also x. So now here we would just have to work this out. That's going to be what, 30 plus... I mean, this we could just use a calculator, or you could just say, was that 54? Yeah, so if you're doing this in your head, I'm just doing this in my head. If you want some mental math, a little side note, you could just do 3 times 20 minus 2, and that's 60 minus 6, which is 54. Okay, so this gives you 54 equals x squared. And then square root this, and then x equals like, oh no, my answer's not there. This is broken. Like, no, like just think more. This is 9 times 6, so you just put it in radical, and the square root of 9 is 3, so 3 radical 6. Choice 2 would be your solution. Okay, cool. This is August 2017. And thank you all for the subscribers, for subscribing. I'm like so happy to like look and see the numbers are absolutely flying here. My goal by the end of the live stream, I mean, whatever, like whenever I get to 24,000 subs, I get there. But I appreciate all of you helping me get there faster. So if you haven't subscribed yet, consider subscribing, because I could be your Regents guy for Algebra 2. And if you wind up in pre-calculus, there's AP pre-calculus now. I teach AP Calculus BC, and I do live streams for the AP math exams as well. So my goal is to just be like the live stream guy for like a lot of the popular math tests. So cool. This will post later. Once it is over, it will stay on YouTube. All right. So we have a rectangle whose length, oh, this is a nice question, whose length and width, let's make this neater. So the length and width are 10 and 6 respectively. And it's shown below. The rectangle is continuously rotated around a straight line to form an object whose volume is 150 pi. So this one, if you were to rotate this around, just imagine like a revolving door. Okay, this would make a cylinder. Okay, so it would look something like this. All right, if you were to rotate this thing, once again, let's add in some new color here. You take this rectangle and you spin it. And when you spin it in this circular motion like this, it's going to form, when you spin the rectangle, it's going to form a cylinder. Now just know the volume of a cylinder, this is, I believe this is in the back of the test. Let me just double check because I did print one out. So let's see. The volume of a cylinder they give you. Okay, so you don't need to memorize this, but if you wanted to, like you could use concepts of Cavalieri's principle, that a cylinder is really just like a stack of circles. Okay, so like the cross sections are all circles, like going all the way up like this. So you could just see here, it's like, oh, the area of a circle is pi r squared times the height. So this is Cavalieri's principle mixed in. So what I would do for something like this, because this question was a little bit difficult, is I would say r, h, and then the r squared h part. Just so you could see. You'll see what I mean in a moment. Which line could the rectangle be rotated around to give us a volume of 150 pi? Well, if we rotate around this side, so let's say we rotate around the long side, that means we're going this way. See, like we'd be going like this. And if we go that way, maybe you could visualize it. The radius would be equal to 6. The height would be equal to 10. And if you did r squared, so you did 6 squared times 10, that would give you 36 times 10, which is 360. And you see here, this doesn't match the 150. Okay, we would need to have like r squared times h gets multiplied by pi, so we would have a 360 in front of the pi, not a 150. If we go around the short side, so now we're going to go around this side here. So for this question, the short side would be rotating around 6. And if we spin this way, so going this way, now the height is equal to 6 and the radius is equal to 10. And if we did r squared, so 10 squared times 6, now you have 100 times 6, and that's equal to 600, which is definitely not 150. So this one is also out. All right, this is a tricky question, so I'm hoping this is making sense. If you rotate around the vertical line of symmetry, so now we're going to bring in a vertical line of symmetry. And if we do this, this is going to be 5 and this is going to be 5. And if we spin around this, now our radius is 5 and our height is 6. So if you did 5 squared times 6, 25 times 6 is 150, which matches the 150 in front of the pi. So this would be the answer, okay? Now, if you just want to explore why the last answer is no good, you just cut it this way horizontally. And if you were to spin this way, now your radius would be equal to 3 and your height would be equal to 10, okay? And you would have 3 squared times 10, which would give you 90, which would be too little. So this one is out. Definitely choice 3. All right. Doesn't your Regents factor into your GPA? That would be like school by school, but usually no, because your report card grades are already in. Your Regents grades are usually separate. But yeah. So here, next up. Oh, all right. This is a good question. Properties of quadrilaterals. And in this case, we're looking at a rhombus. All right. So to anybody just joining, once again, hello. And we're doing August 2017. I really do appreciate the support here. I truly do consider myself lucky that we've already hit 1,340 viewers. All right. And if you have classmates, consider spreading the word. Let them know, like, hey, this guy's reviewing geometry. So, the more the merrier here. I'm happy to just have as many people join this as possible. All right. So question 14, we have ABCD is a parallelogram. So that's what we got here. So it's a parallelogram. And which statement would prove that it's a rhombus? So draw a rhombus out. If you forget, draw a rhombus. And a rhombus, all the sides are equal in measure. Okay, so it's a parallelogram with 4 equal sides. So in a parallelogram, like if we draw this out, A, B, C, D, like this. Angle ABC is congruent to angle CDA. That just tells you like what is true for any parallelogram, that opposite angles are equal. See, ABC is congruent to CDA. Like this is true, okay, for all parallelograms. Okay, so that doesn't make it special, okay? I'm just abbreviating, actually, whatever, I'm already there. Let me write it out. So this is true for all parallelograms. So this is not anything special. AC is congruent to BD. This would be to show it's a rectangle. Okay. Oh, you sent the stream to your class group chat. Thank you so much, Etsy. I do appreciate the support. I really mean it. I'm very happy to see this chat is so active and everyone's being so cool to each other too. I do appreciate that. This really does make it exciting. I'll be 100% honest. Like I do the videos where I make the practice test videos and the live streams. And the live streams to me are always the most fun I have on YouTube, without a doubt. I mean, it's hard to get people to like go to live streams like every day of the school year because, you're like just working at your own pace. But for test reviews, I like so look forward to doing the live streams. It's like just a lot of fun to get everybody here all at once. Like I look at this and say, wow, 370 people are here right now. And like my busiest school year, I taught 170 people. 1,404 people is like about half the size of the school I work at. So like, just thank you for supporting. Do you need to pass the geometry regents to go into trig? Usually you go into algebra 2 after this. It used to be called algebra 2 trig, but to go to algebra 2, like not necessarily. Some schools will just let you go in and they'll make you retake the geometry regents like in January or August. So yeah. Oh, so scared of the regents. So Sheila, just hang in there. Remember, do your best, study as much as you can, and like show up and just do your best in the 3 hours they give you. No matter how it works out, you're going to learn something. So just do your best. Can I do the physics regents? I have to see. So at Meet KP, I taught physics for 2 years because my school had a science teacher shortage. I would really have to brush up. It would be awkward. Like if you asked me, hey, what's a magnet? I would say, I don't know. You throw it and it sticks to your refrigerator. Like I'm very rusty with physics, but I only said yes to teaching physics because it's like basically like math. Like everything's on the reference sheet. So physics, the theme is everything's on the reference sheet and be great at algebra. And like you could kind of just pass the physics regents with that. The sciencey stuff like circuits and electricity, magnetism, all that stuff. Yeah. So to build a handicapped access ramp, I don't know why I underlined that. The building code states that For every 1 inch of vertical rise in height, the ramp must extend out 12 inches horizontally, shown in this diagram. What is the angle of inclination x? And they were polite, they labeled it for us. To the nearest hundredth. Okay. So this one, I'm going to say like it's probably not these, because this is small. All right. And you know, like from geometry, let me just see, how do I say this best? Oh yeah, the largest angle. So the largest angle is, now I could use this, opposite the largest side. Okay, so also the smallest angle is opposite the smallest side. So this is like the hypotenuse. So this is clearly the longest side, because that's just true for any right triangle. So this is the smallest side, so this would have to be the smallest angle. So these answers just don't make sense. So then you could just guess and be like, hey, choice 1, like, yay, I got it right. But I'm going to obviously show you how to do this. Don't guess tomorrow. Unless you have no idea, then don't leave it blank. SOHCAHTOA. All right, this is a very helpful phrase. We have angle x. This is opposite of angle x. So this is opposite of x. And this side 12 is adjacent. Okay, it's adjacent to x. So what I think of here, because sometimes students struggle with this, I say, all right, I'm looking for x, and x is the opposite side. I know 12 is the adjacent side. And then I say, all right, opposite, adjacent, opposite, adjacent. That would be tangent, because tangent of the angle is equal to the ratio of the side opposite the angle over the side adjacent to the angle. So then I would say tangent of x equals opposite of x is 1 over adjacent is 12. So then to solve for x equals, I'm going to do the opposite of tangent, which is tangent inverse. Okay, so tangent inverse of the ratio 1 over 12. So calculator. Let's see. Now, don't let this be you. In this case, they're polite. Like, let's say you forget to put your calculator in degrees. You know, this will be a tragedy. You're like, oh no, math is broken. Like, my answer's not there. I hate math. It's like, no, math isn't broken. You're broken. You should be in degrees. They said to the nearest hundredth of degree. So switch to degrees, and then you type it in. And you get 4.7636, which corresponds to choice 1. All right, now just in case you're like, wait, what does that mean? If I do tangent of this angle, this gives me 1 over, oh, that should have gave me 1 over 12. Let's see. See, 1 over 12 equals tangent of the angle. So if I want to go from this ratio back to the angle, we do tangent inverse. Okay, so just be mindful of that. Okay, this is like a bigger idea, but just know, like in general, when you have something like, you know, y equals tangent of x, like this is an angle and this is a ratio. Okay, but if I want to say it the opposite, I would say like, oh, x equals tangent y, sorry, tangent inverse of y. This, I feed the inverse function the ratio, and it tells me the angle. Okay, so just know the relationship between the inverse functions is really important. All right, very cool. And once again, to anybody just joining, thank you for joining us in this live stream here. We are on August 2017, and we are cruising along to question 16. The replay will be available, so if anyone joined late and you want to know what happened from 1 to 15, you can just rewind back. All right, now this one here, just know this is once again similar triangle concepts. In triangle ABC, we have DE and F are the midpoints of these sides. So if I were to label this here, like call this X, call this X. If they're midpoints, that means like these pieces are equal in measure, like this. And what you should know is that when you connect two midpoints in a triangle, we call this like the midsegment. Okay, the midsegment is when you connect two midpoints. It is parallel to the it's parallel to the side that doesn't include that midpoint. Like, see how F and E are the midpoints of AC and BC? So the side we didn't use was AB. So it's parallel to this side, and it's half as long. So you can see AB would be equal to like 2 times Z. I used X, Y, and Z. So half of that would just be Z. If I cut this in half, you know, like half of AB would just be equal to Z. So that would tell me this is Z. And then that would tell me, like, if this is y, this is y. See how this would be y over here, because this is the side parallel. This is the mid-segment that connects these two midpoints. And then if this is x, and this would be x. So now, notice we have 4 triangles, okay, with the same side, side, side. So these 4 triangles are congruent, okay? So the 4 triangles are congruent. So now, what is the ratio of the area of CFE? So let's see. So CFE is this one. So what is the ratio of the area of CFE to the area of CAB? Well, this is just one part. So CFE is one part. And you can see that triangle CAB is 1, 2, 3, 4 congruent triangles. So it's a 1-to-4 ratio, like this. Okay, so 16, you should be getting choice 4. All right, cool. And let me just make sure I'm following along, just in case I say something crazy. But yeah, 16 should be choice 4. That is definitely correct. All right, I solved these out ahead of time so that my explanations are more crisp. Because if you all see me thinking out loud, it's like sometimes like my first idea just takes way longer. And then I see like a faster way of doing it. So yeah. All right. Oh, wow. The chat is really rolling here. So thank you all for supporting here. Oh, your teacher posted my live stream. Thank you, Moonlight Star. Thank you to your teacher. I appreciate the support from all around, New York State. I might have people coming in from outside New York State. Is anyone? So we probably have a lot of New York City people in the house. But to anyone in upstate New York, Long Island, welcome aboard. Happy to have you on. Okay, so let's see. Oh, these questions. All right, so these are somewhat painful. I'm going to do my best to make this as easy as possible. All right, because if you try to plot this, I'll say good luck, plotting. Okay, and if they wanted you to not be able to plot this, then they could just be like, all right, comma 600, and you're like, oh no, I don't have time to count 600 spaces. And that's the point. They want you to think about this a different way. So what I imagine for this, I'll just write this down. So A, and let me give space. So this is not necessarily drawn to scale. But here's A and here's B. And A is at -8, -2. And B is at 16, 6. So we have to track the X and the Y coordinates section by section. But what they're telling you is point P is on AB, on this segment, in such a way that it splits this into a ratio of 3-to-5. So what I think of when I hear the ratio 3-to-5, that is 8 parts total. So what I'm looking at is, I'm like, all right, well, this would cut it in half. And then I want to cut this into 4 equal pieces. So I would go here, here like this. So you see that's 1, 2, 3, 4. And then I cut this into 4 equal pieces. So you see now we have 1, 2, 3, 4, 5, 6, 7, 8. And now what's actually going to happen here is, because I want you to understand this type of situation. The location of P is that it's going to leave us with 3 equal parts and then 5 equal parts after. So that would be 1, 2, 3. It would be here. This would be the location of point P. So you see we have 1, 2, 3, and then we have 1, 2, 3, 4, 5 equal pieces. So first off, I just want people to understand what's actually happening here. Because once you get this, then the rest is hopefully not so bad. So 8 parts total, and I should say 8 equal parts is really big. So now what I'm going to do is I like to find what is the change in X and what is the change in Y. So pay attention here. We're going from an X1, Y1 to this X2, Y2. So to find the change in X, we're going from -8 to 16. So I could do 16 minus -8, which will tell us our X is going to change by 24. So we're increasing our X by 24, but we're doing 8 equal parts total. So if I took delta X and I divide it by 8, okay, so delta X divided by 8, I divide this by 8, so divide everything by 8, that tells me I'm going to be jumping by 3s. So you could see here that my x coordinate, if I go forward 3, that would give me -5, comma something. So that's this one. This one would give me, if I go forward another 3 units, that would put me at -2, comma something. This one, I would go forward 3, I would be at 1, comma something. And I could already see this is the only one with a 1 in the x place. And then if I keep going forward 3, you could see I would be at 4, comma something. This would put me at 7, comma something. This one would put me at 10, comma blank. And then you could see here we're at 13. And then finally we land at 16. And then my y values, if I want to track my y values, I'm going from from -2 to 6. So 6 minus -2 like this tells me delta y is equal to 8. And we're going 8 parts total. So I'm going to divide delta y by 8. And that tells us that we're counting by ones. Don't worry so much about this notation. This honestly like kind of just goes on in my head. Like that's what I'm just thinking about in my head when I do this. I probably could have wrote with better notation, but whatever. So that means start counting by ones. I'm starting at y is -2. And if I go forward 1, I'm going to be at -1. Then I'm going to be at 0. Then I'm going to be at 1. So you see this matches 1, 1. And I'm going to be at 2. I'm going to be here at 3, 4, 5, and then finally I'm ending at 6. Okay, so that's the idea. If you want the fast way, like the fast, like the too long didn't read or wasn't paying attention, then what you do is like you go, this is like where you're starting. So your final x is going to be like, all right, x equals, I started here, plus like I'm going 3 parts, I'm going forward 3 times my delta x was 3, like this. You see how I did 24 divided by 8 was 3, and then that would just give me -8 plus 9 is 1, and you're like, oh, choice 1, like this. But I like to draw it out because I think it makes it make more like conceptual sense as to what's happening. All right, so moving on here. Yeah, the formula is definitely easier, but at Green Bean, I taught, once again, AP Calculus BC, I taught pre-calculus, I taught geometry, algebra 2. I have to have a million formulas in my head, so I just need to be ready. So yeah. All right, so moving on here. So let's see, what is up next? So we've got, all right, this one. I'm going to say brace yourselves. This question is a lot. So for this one here, just know when you draw an altitude, so we have a right triangle. When you draw in the altitude to a right triangle, you have 3 similar triangles. Okay, so just know here that these 3 right triangles, so the big triangle, the medium, and the small, are all the same. Me personally, I cannot memorize the leg or the altitude rule. If you can memorize those rules, then great. Then we like just move forward from here. So what I like to do is in this big triangle, let's say I call this angle here, I call it theta 1. Then this angle I could call theta 2. And this would tell me, so this is the concept, that theta 1 plus theta 2 plus the right angle, which is 90, equals 180. Okay, which would tell me that theta 1 and theta 2 have to be 90. Okay, because 90 plus 90 would make 180. So in the small triangle, you see if this is theta 1 and this is 90, this would have to be theta 2. And in this medium triangle, if this is 90 and this is theta 2, this would have to be theta 1. And the reason I do this is because the 3 triangles are similar. And knowing where the angles are helps you set up the proportions correctly. So which lengths would make triangle KLM a right triangle? So we need sides that are going to be in proportion. So let's try out choice 1. So we just have to do this kind of by brute force. LM is equal to 13. And we have KN is equal to 6. Well, if this is 6, then this is going to be 10. So right away, looking at this, my first instinct here is to look at the big triangle, medium triangle. So I'm thinking like big and medium. So if we look in the big triangle, you could notice here that I'm thinking like, all right, I'm going to compare, and just looking at this, I'm doing theta 1 over the like 90-degree angle. So just see where I'm going with this. So in the big triangle first, so the big triangle, identify theta 1 is here at angle K. Opposite of theta 1 is 13 over the side opposite of the 90-degree angle in the big triangle is 16. And ask yourself, is this equal to, now go to the medium triangle. Here's the medium triangle. You're comparing the side opposite theta 1 over the side opposite the 90. And opposite theta 1 is 10 over the side opposite the 90 is 13. These don't work out because if you cross multiplied here, this would give you 169 equals 160, which is not true. Okay, so this one's out. Okay, this one is no good. So let's see. I'm hearing here is the Geometry Regents canceled only in Long Island. Why is it canceled in Long Island? All right. Let's just see. I'll put this one. My supervisor would have texted me, and I did not get a text from a supervisor. So I'm going to keep streaming. Yeah, that would make... Your school would be calling you right now, sending a mass call out to everybody. So I don't know if somebody is trolling. But, it depends on the district. Maybe some districts, I don't know if like... But I am still, for New York City, like still on. All right, so getting this out of the way now. Now we shift focus. So now we move to choice 2. So choice 2, we have LM is equal to 12. NM is equal to 9. And we're still comparing like the big triangle to the medium triangle. And now this time around though, it's going to be a little different. See in the medium triangle, 9 is, well actually no, it's going to be the same. Theta 1, 9 is opposite of theta 1 and 12 is opposite of 90. So let's use theta 1 and 90. So now I'm using the big and the medium triangle. In the big triangle, opposite of theta 1 is now 12 over opposite of 90 is 16. Okay? And is this equal to, so that's the question, is this equal to the medium triangle? Theta 1, opposite of that would be 9 over opposite of 90 would be 12. And if you reduce these, this is 3/4 equals 3/4. So this one works. So this would be the culprit, choice 2. All right. Cool. Moving on. So let's see. It's 19 a trigonometry one. Yeah. But they didn't draw the triangle for us. How sad. So let's see here. So we got triangle, right triangle ABC. So I would just draw this out. So right triangle, not drawn to scale. So angle A is 32 degrees. So I'll put the 32 degree angle here. Call this A. B is 90, and then C is up here. AC is 6.2. What is the length of BC? Put an X here to the nearest tenth. So for this one, if we know the 32 degree angle over here, X is opposite. Okay, so X is opposite of angle A. And 6.2 side AC is opposite of the right angle. So this is the hypotenuse. So just think about it. You're saying, all right, opposite, hypotenuse, SOHCAHTOA, and opposite hypotenuse should make you think of sine. So then you say sine of the 32 degree angle equals the side opposite of that 32 degree angle, which is X, over the hypotenuse is 6.2. So then here, if you want to solve for X, just multiply both sides by 6.2. Like this. Now these cancel, and X equals, calculator, unless you have a computer brain, 6.2 times sine of 32. 3.285, whatever. So 3.285, blah, blah, blah. To the nearest tenth, that's going to be 3.3. Okay, so choice 1. Cool. All right, we are, let's see how far. Oh, wow, we're an hour and 14 into this. Yeah. What's a way that the regions can get canceled? So at Rarecoin, well, the year the pandemic started, that canceled regions. Oh, they canceled it for Fortnite. All right, LOL. I appreciate humor in the chat. Don't get me wrong. I am a fan of humor. But yeah, just yeah. So you don't want the regions to be canceled. I mean, look, if you want to cancel, I guess you could just theoretically not feel well and not go. Don't hope for like something terrible. Just show up and take your Regents. 24 hours from now, the Regents is over regardless of how you do. So just show up and do your best. Yeah. Yeah, they definitely canceled the New York Regents in Connecticut. So, yeah, I like the humor here. All right. Remember, in the beginning, I talked community guidelines. I see, though, everyone is being respectful in the chat. So please keep it that way. Pretend that you're in class. You know, some occasional humor is much appreciated. But, yeah, just remember, I said that in the very beginning just to keep it real. Nice emoji. Yeah, I like the... Was that an alligator? Okay. Yeah, no, that's a good joke. Yeah. Oh, yeah, they canceled the Regents in Alaska. Yeah, because of polar bears. So, yeah. All right, cool. We'll just name all 50 states. Someone pick a new state to make a joke. All right. So here we are. And, oh, wow, 412 people on. Thank you for joining. Okay, so question 20. This one's like kind of annoying, so just be ready. So this one, when I hear population densities. So the moment I hear density, I'm like, okay, density is mass over volume. But in the context of geometry and this question, it's density is equal to the mass is the population over like the area. So the population over the area. So here they want us, based on the table above, which states, which list has the states' areas in square miles in order from largest to smallest. So basically, I'm like, all right, D equals P over A, and I need to solve for A. So this is where your algebra comes in, like A times D equals P. So A equals population divided by density. So population divided by density is how we want to be thinking about this. So now I'm going to, actually, I'll just move this because I'm going to extend the table. Okay, I'm going to make this table, you know, a little bit more. And let me see if can I group this? Oh, wait, group. Nice. All right, go notability. Okay, cool. Where's a good spot? All right, I guess I'll shrink this a little more. All right, cool. So we'll go here. So basically, like what I'm going to do is I'm going to add a column for area. So the area we're going to find, and this is all just calculator work. Okay, we just have to type this stuff in. We're going to be doing, once again, the area is population divided by density. Okay, so this, once again, is just all calculator. So this column divided by, I'm sorry, population, this column divided by this column. So you're doing this divided by this all across. So here we go. Let's take a look. So this first one here, if you're bad at fractions, hit alpha y equals enter. This is just a nice little trick to know. You don't necessarily have to do that, but it helps to know it. So 18, 801, 310. And you're dividing by 350.6. So you do that, you get 53,626. So 53,626, and it was like 0.1 or something. All right, so good enough. Now the next one here, we're going to do 12. I don't have to write a fraction for this because it's just one term divided by another term. I don't need parentheses either. So let me just make sure I wrote this correctly. 12830,632 divided by 231.1. All right, so this one's like more tedious. So it's 55519.8. Okay, so 55519.8. And now New York is next. Shout out to New York. All right, New York gets a lot of shout outs in the Regents because it's like, I guess, their state. So it's like always exciting. Like, oh yeah, I live there. All right, so let's see here, divided by 411.2. Oh, whoops. All right, so there, notice I missed. If I was gonna lose a point on the Regents, it would probably be I make a typo. Like at my age, like it's like, oh, I can't see that. All right, so 19378,102, and this should give us 47125.7. So 47125.7. Cool. And then last but not least, Pennsylvania. Okay, Pennsylvania. We got 12,702,379, and we're dividing this by 283.9. Okay, and you get 44742.4. 44742.4. Now you just have to put these in order from largest to smallest. So Illinois wins. So this is like first place, Illinois, which eliminates everything except choice 1. And now we see Florida should be in second place, which, yes, it's more than New York. And then New York is in third place. Pennsylvania is in fourth place. So yay, it worked. All right. So if you know what to do, it's like not bad. All right, this one is a little bit tricky. So what's tricky about this is like if you know the concept, it's easy. Like this is easy if you know what to do. So here, like what I think of is I have a right triangle like A, B, C like this. And let's say I call this, like lowercase a, lowercase b, lowercase c. If I look at sine of angle A is opposite over hypotenuse, is lowercase a over lowercase c. If I do cosine of angle B, adjacent to B is A, over the hypotenuse is C. So what this tells you, like sine and cosine are what we call cofunctions, That means like when sine and cosine are equal to each other, like A plus B like is equal to 90. All right. And now look, I should use proper notation because your teachers will be mad. The measure of angle A plus the measure of angle B is equal to 90 degrees. Like this is better notation. So whatever. If you want this concept illustrated a little better, let me drag this up a little. Like if I did sine of, let's say 35, I know, give me what's the missing number that makes 90. It would be 55. And you see how it gives me the same value. So as long as I plug in complementary angles, like let's say 40 and 50, sine of 40, cosine 50 are going to be the same. Okay. So basically, because these are equal, that means this and this one and this one, these are complementary. So complementary, which means they add up to 90. So 40 minus x plus 3x is equal to 90. So that's going to give me minus x plus 3x is going to give me 2x. So 40 plus 2x equals 90. And now just solve for x. 2 steps of algebra. So the algebra here is not hard, but knowing what to do with all those terms, like that's the hard part. You have to know what's happening here. So 25. I am not going to go through another Regents after this. Yeah, sorry, Brittany. I did go on like, pretty heavy into making Regents videos. So I have plenty of Regents. I have like January 2023. I have August 2022, June 2022. I think I even have June 2021 maybe. But yeah, I have like a decent amount of Regents you could look at for sure. But I'm going to probably, tap out after 3 hours or almost 3 hours. All right. Question 22, a regular decagon. All right, I'm not going to use draw a 10-sided figure because I'll lose my mind. But this decagon is, and regular, I'm doing a lot of like sidetracking here. Let's get ourselves back in order. So regular means all sides and angles are congruent. All right, that's what it means to be regular. Decagon is 10 sides. So the concept for this, let me do a square first. So let's say it was a square. If I want to rotate this, just imagine like it's inside a circle. All right, not my best circle, but you get the idea. And when I want to rotate this, the key is I do 360 divided by n, where this is the number of sides. Okay, because what this tells me is the minimum angle I have to spin this, that it carries onto itself. So just think about it. If you spun the square, if you spun a square, let me redraw this. So let's say here, I spin the square. Let me see if I could actually drag just that one out. Oh, cool. So I spin this thing. Why is this thing like not behaving? Let's see. How could I do this nicely? Oh, maybe if I just screenshot it, because I really want people to get the concept. All right, that works. Wow, that didn't work. Fail. Now it's a giant square. All right, whatever, good enough. And I spin this 90 degrees. Like you could see here, I'm not a great artist, but this thing lands on itself. So to find that mystery angle, just divide 360 by the number of sides. So if I did 360 divided by a decagon has 10 sides, that tells me the minimum angle I have to spin is 36. But I would have to spin by, I'm counting by 36s. I would have to spin one of these multiples, and this would get me to, let's see, plus 30 is 216, plus another 36 is 252, plus another 36 is that 290? Wait, no, 288. Yeah, plus another 36. And then, yeah, and it goes on and on like this. Let me just double check that I'm not like saying something crazy. I could just do this, like just do 36 times x. I don't know why I'm struggling. 36 times x, you get a calculator, second graph. And second window, yeah, I was doing a different question. So I'm going to be on auto like this. And oof, did I really get a, oh, whatever, I'll just scroll. I'm already committed. So yeah, you can see here 216, 252, 288, 324, 360. So whatever we spin, it has to be a multiple of 36. So like 10 is out because that's too little. It wouldn't carry on to itself. 150 is like only is off by 6 degrees, so that wouldn't work. 225 doesn't work because that's not here. 252 is the last one. That's our answer. Okay. Cool. All right. How many people get bad grades? Yeah, I mean, unless everyone got a 0, then like everyone would get a 0. So let's see. All right, moving on. So question 23, we're cruising through. So this one, we have a circle with a diameter of 32. Something tells me we'll need the radius, which is half, which is 16. The area of a sector is this. The measure of the angle of the sector in radians is. All right, so the concept here, because I can't memorize formulas, is if I want the area of a sector, so just this piece, it depends on whatever theta is. Okay, so whatever theta is makes the difference. So what I'm doing is I'm taking pi r squared. That's the area of the whole circle. And I'm taking just a fraction of it. I'm taking theta out of the total spin would be 2 pi. Like technically, like you could say like, oh, 360 degrees is the full circle. But we're talking in radians here. And just know pi radians is 180 degrees. So if I want to get 360 degrees, just multiply both sides by 2. And 360 degrees is equal to 2 pi radians. Like this. Okay, you could do the thing where you go like, all right, 360 times pi over 180 like this. And then like the units cancel, and then this equals 2 pi. That also works. All right, but I'm taking theta out of the total spin, which is equal to this. But this is the area of the sector. And they told us, okay, since we're taking a fraction, this is the area of the whole circle, but this is the fraction we're taking. And that's going to give us the area of the sector, which is 512 pi over 3. So now we just have to simplify things here. So to work this out, the rest is all algebra. So now let me get this out of here. I'll do the algebra on the side. So one thing that jumps out at me right away, let me change colors, is that pi over pi cancels. And we've got theta r squared over 2 is equal to 512 pi. And this is over 3. But r, we just said a moment ago, was equal to 16. So I would make a little substitution here. I'll just do that right here. R is equal to 16. So I'm going to do 16 squared like this. And now we simplify this. That's going to give us, was that 256? And 256 divided by 2, that's going to be what, 128. So we would have 128 times theta equals 512 pi over 3. And then from here, just divide both sides by 128. Okay, so the 128 will go on bottom. And then just simplify. Okay, so this cancels. And now 512 over 3 times 128. Just know if I'm doing that on the main screen, I'm going to do alpha y equals enter. 512 over 3 times 128. And that's 4/3. If you don't recognize it, press math, enter, enter. So that simplifies over here. Theta equals, this messy right side is 4 pi over 3. So this should give you choice 2, which it does. Perfect. Yeah, there's, once again, if that was confusing, because like the questions at the end are like sometimes hard. Like that's just, there's like kind of like almost like no way around it. But the area of a sector, I think we could see here is, what was the formula? It was, oh yeah, theta r squared divided by 2. Yeah. So that's the formula. If you want a formula just to memorize, the area of a sector is theta r squared divided by 2. But what they gave us here is they gave us the radius and they gave us the area. And then you just do the algebra. Okay. Algebra 2 is tomorrow. So at King Algebra 2, I will be live streaming tomorrow for that. Okay. Oh no, my green screen is messing up a little. Let me, I gotta fix this chroma key a little bit. I don't want to start disappearing. Okay. Yeah, cleaned it up a little. Yeah, spoiler alert, I have a green screen. So yeah, I'm not actually like magic. I'm embedded in. Okay. Cool, last one. Nice. Question 24. Here we go. So we want the equation of the perpendicular bisector. For this one, if you want to use a compass, I've seen teachers show it like this. That's like pretty awesome. You could use a compass and be like, y equals 1/2 x. And yeah, that'd give you like choice 4. So you could use a compass. Or you could know the idea, which is you have to find the midpoint. So this is the point -2 up 1, 2, 3, 4. And this is the point 2, -4. Okay, so that's -2, 4. And this is 2, -4. And you can find the midpoint. Okay, so the midpoint you get by taking the average of the x's. So that's -2 plus 2 divided by 2, comma, the average of the y values, which in this case is nice. It's 0, 0. I'm just doing this because if it wasn't obvious that it's 0, 0, like the formula makes it the most precise. Okay, so formulas are good to have. Now, the next thing you can find here is the slope. The slope of this segment, you're going down 1, 2, 3, 4, and over 2. So down 4 over 2. So the slope is -2. The perpendicular slope, call that -2 over 1. You flip and negate. Okay, so if this is negative, now it's positive, and we flip it to 1 over 2. So that is our slope, and our point is going to be here. So for this one, we could just use y equals mx plus b. And this is our slope and our y-intercept. And if we're intersecting at 0, 0, our y-intercept, our b value is 0. Like that's the y value of our, the point where the line touches the y-axis. And the slope, m, we're going to use is 1/2. So you just have y equals 1/2 x. You could tack on plus 0, but you don't need to. And then you look and you're like, oh no, my answer's not there. Like this question is broken. But then just multiply everything by 2. And you get 2y equals 2 times 1/2 is 1. So you get 1x. And then just subtract x. 2y minus x equals 0. Choice 4. Okay. Your teacher didn't teach constructions. Yeah, I mean, it could be for a million reasons. Sometimes schools like just run out of time. That's something they struggle with. So, yeah. Oh, so Adoga, please, yeah, keep it real in the chat. If you're both friends, like that's one thing. But no one's throwing hands with anybody, please. Pretend you are in class is the rule. All right. So, yeah, we get. Wait, I'm gonna throw hands with a Waffle House. Yeah, no throwing hands at anybody. Yeah, let's keep it real in the chat. Behavior management is almost always a part of these, but please, I need to know, like, down the line, I'm going to get moderators to, like, make sure, like, things stay nice. That's relatively harmless if we're just joking. But please, once again, just keep it real. Cool. So moving on here. Now we are in the part 2s. So, let's see. These are 2 points. Sue has some cylinders here, and she believes that the 2 cylinders have equal volume. So this is Cavalieri's principle, okay? Because Cavalieri's principle says as long as the area of the base is the same for both shapes, and the height is the same, then the shapes are going to have equal volume. Oh, no, it's quite all right. I'm just, once again, yeah, let's, this stream is going to go on until the test is over, and then I'll say good luck to everybody. My kids are eventually going to be home, and they're going to be loud. Yeah, I only started monitoring the chat because, like, some people started saying, like, some stuff, like when my kids were making noise in the background. I was like, oh, be nice. Like, you know, they're my kids. I care about them. Like, you know, you could comment on my kids being loud when they start making noise, but yeah, just keep it nice. So what's it called? Yeah, Cavalieri's principle is the fancy name for this one. So do they have the same volume? I would say right away, yes, because you could see here, like the volume of this shape here is pi r squared h. And pi r squared is the area of the base. So the area of the base. And this is the height. Okay, and you can see here, like the area of the base for this shape, it's a circle, is going to be pi times, and it's going to be, 5 squared like this. Now, look, you could say like, oh, I'm going to throw in the units, and I'm going to get 25 pi, square meters. But just know units, you don't lose points for units. So you do not lose points for units unless you use the wrong units. So why risk it? Okay, unless you use the wrong units. Like if I said 25 pi meters to the 12th power, then I'm wrong. But if I leave units out, I lose no points, except for physics. Okay, so just remember physics, units, like different story. In physics, whoops, just resized here. Didn't mean to. In physics, the units really do matter a lot. So just geometry, you get away with it, but whatever. Okay, yeah. So units matter if you have physics this year. Cool. So moving on. So what we got, let's just see here. Let me resize this so it takes up the full screen. Okay, so if we look here at this shape, we could see here like the volume of like cylinder 1. Let me just abbreviate this, like cylinder 1. The volume equals pi times 5 meters squared times the height is 11.5 meters like this. And if you multiply just the numbers, 5 times 5 times 11.5, you could do that in the calculator, is 287.5. And now I tack on the pi, and I would have cubic meters. Okay, so volume would be to the 3rd power. So that's cylinder 1. Cylinder 2, the volume would be the area of the base. So the area of the base is pi times 5 meters squared times the height. You see the 90-degree distance to the top of this tilted one? This is like the Leaning Tower of Pisa, kind of. So this one here would give you 287.5, and then the pi tags along, and we have cubic meters. So I see they have the same exact volume, but we just have to explain why. So the explanation, like we would just say, for one, Sue, is Sue correct? So I would just say like yes or no, like yes, Sue is correct. Okay, so make sure you actually answer the question. Sue is correct because both cylinders, just to make it like fancier, both cylinders have the same height and base area. Okay, because once again, Cavalieri's principle, you don't actually have to cite Cavalieri's principle, but the area of the base times the height gives you the volume of both cylinders, and they have the same base area and height. So that's it. Okay, I didn't plug in the pi because like this is like just like in a way like not more precise, but it's just one decimal. If I plug in pi, it's going to be a very messy number, like 287.5 times pi. This is going to get like very, very, very messy. See, like 903.207 and whatever like this. It gets pretty messy. Cool. All right, moving on. Question 26. So we have a rhombus here. It's rhombus PQRS, and diagonals PR and QS intersect at point T. And we have PR is equal to 16, QS is equal to 30. So PR and QS are the same. One thing you want to know here is diagonals are perpendicular and they bisect each other. Okay, so this is for when you have a rhombus. Okay, so this is true when you have a rhombus. The diagonals are perpendicular. That's unique to like rhombuses and squares and whatnot. But the diagonals bisect each other. That's true because it's a parallelogram. So right away I see like, all right, PR is 16. So this would be 8 and this would be 8. So the whole thing is 16. We're cutting it in half. QS is 30. So that would be 15. This would be 15. And these are all right angles like this. So we have 4 right triangles, congruent right triangles. And we want to know, determine and state the perimeter of PQRS. So here, if I want to say like, what is PQ equal to? Notice that we have a right triangle on the side like this. And this is an 8, 15, 17. This is a Pythagorean. Okay, so a Pythagorean triple. If you're like, hey, how'd you get 17? If you just know that, great. And just know for the SAT, when you will eventually take that, that's something you want to know, some of the Pythagorean triples. But like 8 squared plus 15 squared gives you 289. And if you take the square root of that, so let's say I do Pythagorean theorem on this, I get, what on earth did I just, oh, I pressed L2. Let's try that one more time. All right, 8 squared plus 15 squared. Okay, and I do the square root of 289. I get 17. Okay, so that's where that 17 is coming from. So that tells me like this is 17, and because it's a rhombus, so this is true. Also, like all sides are congruent. Okay, so all sides are congruent tells me this is 17, this is 17, this is 17. So the perimeter of PQRS equals 4 times 17, and this is going to equal 68. All right, so that's work shown. Remember, these are only 2 points. So yeah. All right, let's see, moving on. Ooh, this is a nice one. All right, there's a lot of ways you could do this one. Question 27. So this one, like, you kind of need to be able to visualize things. So let me zoom out. Actually, I'll zoom out in a little bit. So describe a sequence of transformations that would map quadrilateral math onto quadrilateral M double prime, A double prime, T double prime, H double prime. Just know you can do it in one step. The sneakiest way to do this is actually if you do 180 around this point. Let me zoom in a little bit. So if you do 180, like 180 degree rotation, about the point negative half half, that's how you do it in one. So this is like this is you doing it in one move. Okay, so this will get it done in one move. But chances are, like, people aren't going to do this in one move. I don't know how many students did this in one move. There's definitely at least one student that solved it in one step. But realistically, what I would do first is rotate this 180. So when you rotate something 180 degrees, clockwise or counterclockwise about the origin, so like you take this point, it just switches the x's and y's like this. It changes the signs of the x's and y's. So like something like this is the point 2, 1, 2, 3, 4. So the point like here, like 2, 4, would now go to -2, -4. So it would go left 2 and then down 1, 2, 3, 4 like this. Okay, so it sends you here. But to be honest, I think the easiest way to see this would be to target the origin. Okay, the origin, because if it works for one point, it has to work for all of them. So if you rotate this point like 180 degrees, it's going to still be at 0, 0. And then you have to go to the left 1 unit, up 1 unit. So what I'm thinking is like, okay, rotate 180 and then translate, go to the left 1, up 1. Like this. And that'll do it, okay? Like that's my thought process, because I'm imagining like when I, flip things this way, once again, this is 1, 2, 3, 4, up 2, -2, 1, 2, 3, 4. Like this thing here, like if I were to do all the points 1, 2, 3, 4, 1, 2, 3, 4, it would go -1, 2, 3. I can't count. 1, 2, 3, 4, 1, 2, 3, 4. See how, yeah, like, and then 2, 4 would go to, so let's see, yeah, 2, 4 would go to -2. Oh, we already did that one. So 4, 2 would go to -1, 2, 3, 4, and then here like this. So you see, like, this would be the first part here. If we just reflect, I'm sorry, not reflect. If we rotate 180 degrees, it's going to look, and I'm a bad artist, it's going to look something like this. Okay, so that's rotate 180, and then I have to move this to the left one, up one, and it's going to fall right on top. Okay, so describe a sequence of transformations. Now, one thing I don't want you to lose points for. You would say rotate MATH 180 degrees. Specify direction, clockwise, and also the center. If you just say 180 degrees clockwise, but you don't say the center, then you're in trouble. So 180 degrees clockwise about the origin. Okay? And then you could say, and then translate, you could say 1 unit left, and then like 1 unit up. Okay? So translate 1 unit left, 1 unit up. And then you're done. Like, that's it. Okay, cool. So let's see. Oh, constructions. All right. So call this like a brief intermission. I have to just change my device here because in order for me to do the construction here, I need to have this program Smart Notebook open. Okay, so let me just get that open, up and running here. So we have to construct a hexagon in a circle. All right, so this one is like not too bad, but it's also like, it can be a little annoying. So let's see, open. So let me just see. All right. Why is this thing frozen? Yeah, just give it a second. I don't know why it's like. Oh, here we go. Wait, is it? Yeah, I just have to get my program changed here for the compass tool. Yeah, this thing is really just not happy right now. Hang on. My computer is like fairly like good too. It's just, I guess, yeah, there's a whole lot happening right now. All right, let me see. Maybe if I go, why is this thing freezing? All right. All right, notebook. I gotta quit notebook. All right, and let me just see. Let me try that one more time. Yeah, I have to open a special program to do the construction because I don't want it to be like complete garbage. Like, I want it to actually look good. So that's, yeah, why I'm taking my time here. All right. Maybe now is it good? I think we're good now. Let's see. So let me go back to sharing this. All right. This, I guess, the best I could do right now. So let's click here and let me get a circle. I know this is not the exact like question we were on, but the question here was to construct a regular hexagon inscribed in circle O. So I just went ahead and like opened this program here because this one actually has a compass tool for me to use. So I could like show you on this. And you know what? Let me make a smaller circle so that like I don't run out of space to do the construction. I made that circle way too overpowering. All right, so something like this. So what you do is you just pick a random point on the circle. So let's say I say, all right, there. That's going to be my starting point. So you mark it and then leave all the construction marks. So what you want to do is you actually want to measure here. And, you know, you could always have like just a few extra. You don't want to like go too nuts here. But let's say this. All right, so I make one and then I just go around. I go 1. It's essentially the equilateral triangle concept. So I'll show you like why this works in a moment. And then you just go all the way around like this. So 2. This one's like pretty nice. 3. And then next is this one here. 4. Yeah, this one's like a little tedious. It's nice though. I actually really like the constructions. I know some, like, even teachers are like, oh, they're so outdated. Like, why do we even do this still? I just think it's like pretty nice to see like where all these shapes come from. Now, I know this like didn't like, come out perfectly here. Like, it missed by a little bit. That's because like the software itself is not perfect, but like whatever. I'll just say like, all right, I started here. So that's where I started. And now when I connect this, you see I have 1, 2, 3, 4, 5, 6. All right. And the reason why this is working, why did this construction work? So that's like a pretty decent job on that part, is if I go ahead and draw in a regular hexagon. So there's a regular hexagon. A regular hexagon, 6 sides, is made up of 6 equilateral triangles. So like that's the idea. When you do the equilateral triangle construction, you set the compass the same length the entire time, and then like you never change it again. So like that's why the process works. Like you just pick a point, you measure, and then you just keep swinging it all around like this. And it's going to like use the equilateral triangle construction, and that will get you what you need. Okay, so that's why that one works. So now let me get rid of this. All right, so that one's done. Yeah, that was like, I like never look forward to doing the construction on live stream because of the fact that I have to change programs, because I don't believe Notability comes with that option. Okay, so question 29, we are looking at, we have a line segment here, and we want to determine the length of A prime, B prime, the image, after dilating by a scale factor of 1/2 centered at the origin. All right, well, basically, like what I'm thinking of here is that when we do a dilation of a half, it's going to cut the distance in half. So it's going to cut the distance in half. Like whatever the distance is between the points, that's now going to be cut in half. All right, so that's like where my head is going. So what I could do here is I could use the distance formula. I could say, this one, or I showed this earlier, how to graph these points and to use the Pythagorean theorem. So like if you forget this, like, oh no, I forgot this, then you just go like, and you plot this like, all right, 2, 1, 2, 3, and then 3, 4, 5, -1. It would be down here. So this would be like, 2, 3, 5, -1. And if you made this into a right triangle, you see like this would give you the legs like this. This would be a distance of 4, and going from 2 to 5 would be a distance of 3. So this one, it looks like the distance is nice. It's just a 3, 4, 5. Okay, so this is a 3, 4, 5. Otherwise, like, hey, I like the distance formula. Then use the formula. You would have 5 minus 2. So call this x1, y1, x2, y2. If you use the formula, x2 minus x1 squared plus y2 minus y1, and you're squaring it, is going to give you, you're going to have 3 squared is 9 plus -4 squared is 16, which is square root 25, which is equal to 5. But that's the distance. I could rename this. I could actually just call this the length of AB. Okay, so this is the space between points A and B. So AB is equal to this. And let me make that a little neater. So AB equals this. So what is the length? Or I could just say this. A prime, B prime is equal to half the length of AB, which was 5. So this is just 5 over 2. Okay, or I could say 2.5. Either one of these is okay. All right, and if you want to specify, this is the length of A prime, B prime. Make that neater. So there we are. Cool. 29 conquered. Moving on. And once again, I'm just oh wow, Forest Hills High School all the way out. Yeah, shout out to well, just how about, yeah, I don't know if shout out is the right word. I'm just kind of tired. It's been a long day. But just hello to everybody, and thank you for joining here. We have 500 people on. We broke 3,200. I'm just like so happy about that. If you have not subscribed yet, please consider subscribing. I will be doing these Regents videos into the foreseeable future for algebra, geometry, algebra 2. Someone asked me if I could do physics. Oh, I might. I don't know. I got to like talk to my wife and see if she'll watch my kids while I do, physics. Because not just thank me, but I got to thank her too for making this possible. Because, yeah, she's watching the kids right now. All right. But yeah, I do live streams for algebra, geometry, algebra 2. I'm currently starting to add in the younger grades as well. So I've been starting to do the New York State videos for grades 3 through 8. It's kind of like a nice change of pace, like, because that math is like, you'd be surprised though, like that math is not necessarily like completely easy. It definitely has some twists and turns to it. All right, so we have the diagram below of triangle ABC and triangle XYZ. And here we go, a sequence of rigid motions. And just know rigid motions, these preserve distance and angles, which means like the triangles will be congruent. And this is going to map angle A onto angle X. So if A lands on X, that means these angles are going to be congruent. Because if it maps onto it, that means it's like falling perfectly. They're the same measure. C is going to be mapped to Z. So this angle and this angle are the same. And then we're told AC, that's this side, is going to map onto XZ. So now when I look at this, I think of the postulates. Okay, so angle, side, angle, 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 side, 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 angle, side, hypotenuse, leg. Please don't ever write this. Okay, the donkey theorem is not valid. Don't ever use that one. Okay, that's not a theorem. So you got to think, which one of these does it look like? This one is going to be angle, side, angle. Reason being, the side is between the two angles. Okay, the two pairs of angles that are congruent, the side between them is also congruent. So determine and state whether BC is congruent to YZ. So we're focusing on this side here. Is BC congruent to YZ? And I'm going to say right away yes, because they're opposite of the same angle. So these two triangles are going to be congruent by ASA, but then the corresponding parts of these congruent triangles are congruent. Okay, so like I'm also thinking of this. CPCTC, which stands for corresponding parts of congruent triangles are congruent. If you want a fun way to remember this, you could say constipated people can't take craps. Okay, that's how I remember it, just in case you mess up the lettering. But yeah, CPCTC. So determine and state whether these are congruent, explain why. Well, I would say here, like that what we could say is that because we have a sequence of rigid motions, rigid motions preserve distance and angles. Okay, so rigid motions preserve distance and I wrote and angle measure. So yeah, rigid motions preserve distance and angle measure. So, from the givens, we could say, angle A is congruent to angle X. So let me just fix that up to angle X. Then we have AC is congruent to XZ. And then we have angle C is congruent to angle Z. So therefore, just know therefore, that means therefore. Use that, it looks cool. So therefore, triangle ABC is congruent to triangle XYZ by ASA. So therefore, we could say BC is now congruent to YZ since corresponding parts of congruent triangles are congruent. All right, just remember, question 30, like this is only 2 points. So you don't have to say like a whole lot, but you got to say enough. Cool. All right, moving on. All right, so moving down the line here. 500 people are on this live stream. Thank you so much for joining. I'm just like so happy here to have all of you here. Thank you Like, truly, just thank you for supporting this. Just remember, these are all still 2 points. So yeah. Oh, so Waffle House, it must be like some meme. I don't. Yeah, according to MTV, you're old once you pass 25, and yeah. So I guess I'm like still like I'm considered to be old. So I didn't get the Waffle House joke just yet, but maybe someday. So formula, you need this. When you have center, and let me fix this pen so it actually looks like a pen. So center HK, and that was not my best. Center HK, and the radius R. You're going to have this formula. X minus h squared plus y minus k squared equals r squared. So this one is completing the square. Uh-oh. So for this one, I would rearrange stuff. I would group these together, like x squared minus 6x, leave a space. And then I would group these together, y squared. Oh, they're not even on the same side of the equal sign. That's a fail. All right, not a big deal. So we'll have plus y squared. Everyone okay with this little bit of algebra? I'm going to add 8y to both sides. So I'm going to go plus 8y. Like this, I'm going to leave a space, equals, and then 56 is going to be all by itself. Okay, so I'm basically just like moving this to the other side like this. So move, so I move and group. Okay, I want these together. Now, to complete the square for the first part, I think, all right, half of the b term. So the b term is -6. Cut it in half and square it. It gives you 9. And that tells you what to add to both sides. So I'm going to add 9 to both sides. Now, for the part in pink, the b term is 8. And if I cut it in half and square it, that's going to give me 16. So now I'm adding 16 to both sides. Okay, now this will factor nicely. Like, why do we do this? This is called completing the square because now this is a perfect square trinomial. And what we mean by that is when we factor it, you need two numbers that add to -6 and multiply to 9. And that's going to be x minus 3 times x minus 3. See how they match? That's a good thing because x minus 3 times x minus 3 is x minus 3 squared. So I could just write this now as x minus 3 squared. That's why it's a perfect square, because it could be represented as one factor times itself. So now the next part for the stuff in pink, this would be two numbers that add to 8 and multiply to 16 are going to be 4 and 4. So you'd have y plus 4 times y plus 4, or y plus 4 squared, equals. And on this side, so when you combine all of this stuff, let's get rid of that stray mark. That's going to give you 25 plus 56 is 81. So now it's in this form here. See, that's the equation of the circle. So now we just have to identify what is the center. So determine and state the coordinates of the center. The center, HK, the trick is it's just opposite. If I have x minus 3, my x coordinate center is going to be 3, positive 3. And y plus 4, my y coordinate for my center is the opposite, minus 4. Like this, because if you were to plug this into the formula for h and k, it would give you what we have here. And then just be careful, your radius, the radius, like r, is equal to 9, because r is being squared. And you see how 81, what you should be thinking about, like, oh, 81 is equal to 9 squared. Okay, so that's how that works. So moving on, we are going to question 32. Making good progress here. And now the questions are worth 4 points. How many more questions do we have? 1, 2, oof, 3, 4. Oh, 4 more. Is that it? Really? Oh, 5. I lied. Oh, and that last question is really just like really painful. So bear with me. All right. So let's get rolling here. Let's get through this. How long are we into this live stream? We are 2 hours in. All right, so PQR, I'm going to move, like, not super fast, but a little bit faster. So how did I do this one? Oh, I drew this one out, didn't I? Of course I did. All right, so let's see. Because I don't, yeah, I do these a little bit different than, like, how you'll see in the answer key. Sometimes I'm, like, on the same style as them. So here I would just plot this. P, -3, -1. Q is 1, 1, 2, 3, 4, 5, 6, 7. So that's Q at negative 1, 7. And then R is at 1, 2, 3, 1, 2, 3. So here it is. And the next thing we're told here is points A and B are the midpoints of PQ and RQ. So if we connect this, PQ and RQ, A is the midpoint, which I didn't draw this amazingly, but it's looking like this. If I want to be precise here, A, I could say is the midpoint of, let's see, of PQ. So find the midpoint of these. It would be negative 3 plus negative 1 over 2, comma, I would have negative 1 plus 7 over 2. And this would tell me A is the point negative 2, comma 3. So negative 2, 3 is checking out for A. So that's looking good. And then B is the midpoint here, which looks like B is going to be at 1, 5. Over 1, up 1, 2, 3, 4, 5. All right, so this is good. And what are we trying to do? Use coordinate geometry to prove that AB is parallel to PR and is half the length of PR. Okay, so now what we're doing here, let me just fix this. So just so that we're clear, is our goal is to prove that this segment and this segment are parallel and that AB is half the length of this. Now, if I had to really be precise about the location of B, it doesn't hurt. I could just throw this in. So let me group this and shrink this. So this is how we found A, and let me just, this is all together now. So now if I want to find B, B is the midpoint of let's see here. Let me see. B was the midpoint of RQ. Now we already found it, but let's say once again I have to do like negative 1 plus 3 over 2, and I have to do 7 plus 3 over 2 like this. And that would give me B is at 1, 5. Okay, so I'm just showing that work. So now to prove that they're parallel, show that they have the same slope. Okay, so I would find the slope of segment AB is equal to, and now you're using the slope formula, which is y2 minus y1 over x2 minus x1. So just find the slope between A and B. So this is like your x1, y1, and this is your x2, y2. And if you use the slope formula, this is going to be 5 minus 3 over 1 minus negative 2, which is going to give you 2/3. Okay, so your slope should be 2/3. Now you find the slope of PR. So the slope of segment PR, now you're repeating this. You have 3 minus negative 1. So subtract the y values and then subtract the x values. 3 minus negative 3, which is 4 over 6, which lo and behold also equals 2/3. So since segment A, actually, let me write it properly. Since the slope of AB equals the slope of PR equals 2/3, we could say that segment AB is parallel to segment PR. Okay, so that explains why they're parallel, but we have to show also that it's half the length of PR. So distance formula twice, or use the diagram. So here you could see to get from here to here, I'm going up 1, 2, and over 1, 2, 3. Right, I'm going up 1, 2, and over 1, 2, 3. So I'm going up 2, and I'm going over 3. Okay, which makes sense. Our slope is 2/3. So AB, the distance, I could say is equal to the square root of 2 squared plus 3 squared. So I'm essentially like taking this into like a right triangle situation, like 2, 3, and then like call this like, I don't know, call it like W, let's say, and saying like 2 squared plus 3 squared equals W squared. Okay, like that's the math I'm kind of like just doing fast here. You don't have to write it out so like, you know, in depth like I just did. That's why like this work is sufficient. So AB is equal to 4 plus 9 will give you square root of 13. But then remember, we found the slope of PR to be also 2/3, but to get there, we had to go up 4 over 6. So it was like up 4 over 6. So now the length of PR is going to be the square root of, we'll have 4 squared plus 6 squared. And this is going to give us PR equals 16 plus 36 is 52. And if you break this down, PR equals, that is square root of 4 times square root of 13, which is equal to 2 square root of 13. And check it out. How do we know that AB is half the length of PR? Because if you divide 2 radical 13 by 2, it's equal to this. Okay, so prove that PR is half the length of PR. So I would just say here, half the length of PR is equal to 1/2 to radical 13, which equals radical 13, and that is equal to the length of AB. Therefore, just summarize it with a sentence, AB is, or segment AB is half the length of segment PR. Okay, like that is the nicest way we could explain it, I would just say. All right, cool. Very nice. Let me just see anything in the chat. Nice to have people joining on. Focus on multiple choice. Yeah, multiple choice. I mean, look, if you try to just pass with the multiple choice, though, that's a very risky strategy. You definitely just want to like do your best on every part of the test. Just try to like do as much as you can. You know, don't try to just from experience. If you show up to a test saying, "Hey, I'm just going to be really good at like one thing," like you don't want to be a one-trick pony. You want to try to be as good at as much as you can. So yeah, just think about that. All right, 33, a proof. Yuck. All right, so here's one of the proofs here, and let's just see how we're doing on time. So let's see, we are, oh wow, 2 hours, 10 minutes. I know I'm taking long to explain stuff. If I was going on my own, I go way faster. So I'm going to give like the expedited version of this. So statement, reason. So I would say like one, like just copy the givens. I'm not going to let you watch me do that because that's just going to bore everybody. So given. So why is everything in the given true? Because it was given to us. And we're trying to prove that BC over CA. So BC, so this over CA is equal to AB over EC. So what I'm noticing right away, like when I think about those two, so maybe I'll use a highlighter. So we're talking about this, and so BC, BCCA, and then this, and EC, is that it involves two triangles. So my strategy here, like I'm like, oh, this is a proportion. Similar triangles. Which triangles are affected here? It's like, you know, triangle ABC and triangle. If I put them in the correct order, A to B to C, that looks like a right angle. A to B to C, and then E to C to A. So my goal is like, all right, let's show these are similar. Now, how do we know this is true? Well, one thing we can say here is they told us chord BC is parallel to the secant. So these are parallel. So right away, I'm seeing that Z shape. We have alternate interior angles here. Now, I'm going to put a 1 and a 2 here because when I make my statement, I want to say angle 1 is congruent to angle 2. Now, to write this out, I don't know why I wrote a 2 here. This should have been 1. So for this, I say when parallel lines, so parallel lines are cut by a transversal, alternate interior angles formed are congruent. Okay, if all you say is like, hey, like alternate interior angles, like they might dock you a point. So, and also to show two triangles are similar, I'm going to use angle, you know, similarity. So right now I have one pair of angles are the same. Now, the next thing I would look for here is they told us two things that is also helpful. They told us that EC is a tangent EC. So since EC is a tangent, that means that this angle here is 90 degrees. So this angle is 90 degrees. And the fact that angle B is inscribed, and they told us, let's see, where's the word diameter? Is drawn to diameter AC. Okay, so AC is a diameter. Tells us this inscribed angle is also 90. So you see, that's our second pair of congruent angles, the two 90-degree angles. So now we just have to be able to state all of that. So here, let's say angle ACE first. So angle ACE is a right angle. And how do we know it's true? This is really just by like definition of a tangent line, okay? But we could just say like a tangent line. So a tangent line forms a right angle at the point of tangency. At the point of tangency. In this case, at the point of tangency. In this case, like with like AC. Okay, so and the point of tangency here is at point C. Okay, so at the point of tangency, if I want to say like at, let me just maybe add a little bit to this. I don't have to say it exactly this way, at point C, and then say like, you know, the point of tangency with AC. That's like just by definition of a tangent line, okay, that it forms the 90-degree angle here. Now, the next thing I would do is say that, hey, angle B or angle ABC is a right angle. So angle ABC is a right angle. And how do we know? We could say angle ABC inscribes, you know, half of the circle. Half of circle O. And then I could put in parentheses here, like since, like, you know, AC is a diameter. All right, so sometimes like the more you say, like the better, because it's just being very descriptive. But now I have to actually say that the angles are congruent. So next up here, I would say like, oh, angle ACE is congruent to angle ABC. And that would tell me like that's true because all right angles are congruent. Okay, I'm kind of rushing through this a little bit because like, you know, I have to finish and like just kind of call it a day here. But that's the idea. Okay, so angle ACE is congruent to angle ABC because all right angles are congruent. But now what that just proved is that ABC and ECA are similar. Okay, so now that allows us to say that triangle ABC is similar to triangle ECA. And this is true by angle-angle similarity. And now for this one, I would just think, how do I set up the ratio? So I could say BC over CA. So now pay attention to this. BC over CA. This is going from the first triangle to the second triangle. So BC over CA. So you see that's in triangle ACE. So BC over CA, you see that's the middle letter, last letter. So BC and then middle letter, last letter here is CA is equal to, and AB would be the first and second letter. So that would be the first and second letter over the first and second letter here is EC. So you see how everything is in nice corresponding order because we wrote the letters in the appropriate order. Okay. But once again, if we look AB over EC, that would be, you know, this side here corresponds to this side, which makes sense because they're right triangles. And this is like the long leg corresponds to the long leg in this right triangle, and the short leg in this right triangle corresponds to the short leg in the other right triangle. And why is this true? We just have to write our concluding statement here, because corresponding sides of similar triangles are in proportion. Okay, so that is the idea. All right, that one is done. But then we have a triangle proof later, which is like kind of, so yeah. All right, can't do proofs for my life. So look, the thing with proofs is if you don't know what you're doing, try to just say like a few things correct other than the givens. You know, like if you said here, like, hey, angle 1, angle 2 are the same. When parallel lines are cut by a transversal, alternate interior angles are congruent. They will give you a point just for saying something like somewhat on point. Oh, at Emmett King, you're so welcome for doing the review. Thank you all for supporting this thing. Like, I would say I'm getting just as much out of this, if not more, than all of you are. It really does mean a lot to have this many people on. 550 people, 4,120 people stop by. That is, I work in a pretty big high school. That is like more than 1,000, like 1,000 more students than that go to my high school. So I'm like just truly grateful to have you all here. So thank you. But yeah, I mean, look, at this stage of the game, just focus on what you could do. Remember, similar triangles is the biggest one. Okay. No, you get nothing for the givens. Sorry. You don't get mercy points. That's just like how the world works, sadly. As you get older, like you kind of find out more. It's like you either get it or you don't. Like that's just how things work. Like sometimes they'll be nice to you, but other times no. All right. So question 34, we're almost done. Kira has a square poster. She's framing, placing it on her wall. So we have the diagonal is 58 centimeters. It fits exactly inside the frame. The width of the frame all around the picture is 4 centimeters. So this is 4 centimeters. This is 4 centimeters going this way like this. And then like up here too. Okay, so when I did this question, I just kind of made cuts here. So when I made the cuts here, I cut it like this, and then I cut it this way. You'll see why in a moment. Because our goal here is to determine and state the total area of the poster and the frame to the nearest tenth of a square centimeter. So because this was a square inside, I called this x and x. And I know that x squared plus x squared is equal to 58 squared. And if we work this out, this is going to give us, we're going to have x squared plus x squared is 2x squared. Okay, equals, and for this one, I could just, once again, I'll go to the calculator. And let me actually do this in a way that it doesn't completely remove the screen. So now if I go back to it, yeah, that's better. So 58 squared is 3364. Okay, so 3364, and then divide both sides by 2. And that tells you that x squared is equal to, and x squared works out to 1682, like this. All right, so we're going to pay attention to this value in a moment, but then we could say x is equal to the square root of 1682. So the reason why I'm breaking it down like this is that now to find the total area, now we have to be very careful what we say. So for one, you see how it's the poster and the frame. So I could say the total area equals, and I would do x times x, but think about it, the area of x times x is just equal to x squared, which we already said is 1682. All right, I mean, I could make the substitutions in a moment, but once again, the poster, I'll put that on the side. So the area of the poster is equal to x times x, which is x squared, and that we already found is 1682. So this is the area, so this is the poster, and now here comes the frame. Okay, the frame we're going to do in sections. So you see here, like this distance across is 4. So the width all around the frame is 4 centimeters. So that means this would be 4, this would be 4, and this distance here would be 4. So you see how we have a rectangle here? And this rectangle, if I were to like expand it out like this rectangle specifically is going to be 4 plus x plus 4, which would give me x plus 8. You see how I have to go 4 plus x plus 4? So that's that distance across, and this would be 4. So I would have the area of this rectangle would give me, I would have x plus 8, but we just found x is square root of 1682. So now I just add the area of the frame here. I'm going to have in parentheses, x is square root of 1682. So just make that neater. And then plus 8. Let me put the, the 8 first, so it looks less potential for confusion. So that's this times 4. And that gives me the area of like one of these pieces. However, that's just the area of this one. Notice by symmetry, this thing on top has the same area. So this I would just multiply by 2. And now plus, see, this is like the frame, like the horizontal part. So the horizontal part. Now the frame, and I'm talking about like the vertical part now, I'm focusing on these pieces, which this distance now is x. So let me change colors here. So this distance here is x, and this distance is 4. So the vertical piece is like this. This is going up x, and x is here, and then this is 4. So the area would just be 4x. So plus 4 times x is square root of 1682. But once again, there are 2 of them. This is the area of one piece, and the other piece over here has the same area. So just times that by 2. And now the rest, you just have to plug it into the calculator very, 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 very carefully. Okay, so that's what we're going to do. And what's nice about these whatever's the T1000 is that you could just type it in, 1682 plus parentheses are nice. 8 plus square root 1682. So we get out of here. And now times, if you want to, look, if it's the Regents, be honest, how many of you are going to be nervous to make sure 4 times 2 is still 8? Then just write this. No one's going to judge. Maybe a little bit. So 4 times square root of 1682. So 1682, get out of there. Close, open, 2, like this. And we get 2402.2. So 2402.2 square centimeters. You don't have to write the units because if you write it wrong, LOL, you lose points. Okay? Cool. All right, part 4, triangle proof. 6 points. So this is going to be a little painful. Okay, 6 points. So this one here, we have an isosceles trapezoid. Bases DC and AB are, let's see, DC and AB, and the non-parallel legs are AD and BC. Since it's isosceles, the trapezoid, well, for one, these sides are parallel, and these sides are congruent because it's isosceles. And we have segments AE, BE, CE, and DE are drawn. Cool, such that, all right, here we go, CDE. So CDE is congruent to DCE. So this is an isosceles triangle. And we have AE is perpendicular to DE. So this is the same. And we have BE is perpendicular to CE. So that's all the givens. Okay. This, they didn't tell us these are congruent, but that's a result of it being an isosceles trapezoid. So just be mindful of that. So here, I'll just say statement, reason. Like 1 is the given statements. So write the givens. Like why is it true? Because it's given. But this, copy at the Regents. But I don't want you all to watch me write like 12 sentences because I'll just lose my sanity. So yeah. Now, if we look here, I'm going to do the expedited version here. Or maybe I'll just write it out, whatever. So I'll just say, yeah, angle 1 and angle 2 are right angles. And why is that true? Because perpendicular lines form right angles. Okay, so they told us AE perpendicular DE, BE perpendicular CE. So they're right angles. But please, from this point here, what's it called? You want to say also that the lines are congruent. I'm sorry, the angles are congruent. Now, what I'm like kind of going through in my head is I'm going through a strategy here. So maybe I'll do the strategy before I start writing stuff. Prove that triangle ADE, so that's this triangle, is congruent to triangle BCE. So that's why I'm focusing on these triangles right now. So right away what I see is like, all right, right now they have one pair of congruent angles. This side is the same. And let's think what else we know. Well, we know because this is an isosceles trapezoid that these angles are going to be the same. So like this angle and this angle. So I'm seeing subtraction postulate. I'm seeing that this angle here is congruent to this angle here. So now we have angle, angle, side. So I could use AAS in this case here. Another way of doing this would be to use hypotenuse leg because, so there's many styles for this. You could say, oh, this is an isosceles triangle over here. So that would mean like this side would have to be congruent to this side because the sides opposite the congruent angles are congruent. So by HL, these two triangles are the same. So it's up to you. Like that's the nice thing about the Regents, if that's even what you would call it, is there's more than one way to do these questions. Grading this question is actually a nightmare because there are so many ways of doing it. Okay, but whatever. I'm going to just go the AAS route because that's the first one that jumped out at me. So angle 1 is congruent to angle 2 because all right angles are congruent. Okay, so that takes care of the pair of angles. So now next what I would say here is, notice in the givens we said that CDE, like this angle, is congruent to DCE, but we didn't say the big angle yet. So that's the next thing I'm going to say, and let me change colors here, is I'm going to say the big angle. So angle, let's say ADC is congruent to angle BCD. Okay, so those are the big angles here that I highlighted in purple. And why is that true? We could say in an isosceles trapezoid, I'll say both pairs. Both pairs of... Actually, let me think of a better way to phrase it. In an isosceles trapezoid, I'll just say the base angles are congruent. The base angles are congruent. Okay, I could even emphasize here, like both pairs. Okay, like this. So in an isosceles trapezoid, the base pairs of angles are congruent. So that means like this angle is congruent to this one, and angle DAB is congruent to angle CBA. All right, but now think about what we just stated. The big angle is congruent to the big angle. This piece is congruent to this piece. So the leftovers here, if I highlight it in, let's say, pink, like this angle has to be the same as this angle by the subtraction postulate. Okay, so now, like essentially what I'm doing is I'm subtracting, I would say here that angle ADC minus angle, and we're calling that other angle here CDE. So CDE is congruent to angle BCD minus, and then we have angle, I'm just making sure I'm saying this right, DCE, like this. Okay, so you see I'm subtracting, this is like the big angle minus like DCE is the small angle. And what that leaves us with, like the, the complements of this, let's say I call this like, angle 3 and angle 4. I like to use numbers here, so I don't have to keep writing letters, but that would tell me like angle 3 is congruent to angle 4. And this is true by the subtraction postulate. So subtraction postulate. Okay, so now we have two pairs of angles are the same. So now the last thing we want to establish here is we want to establish that like, the pair of sides is the same. Now we could target AD and BC, or we could even do DE and CE, because remember, this is an isosceles triangle here, so these sides and these sides would be the same. So we have so many possibilities here, but whatever, I'll just pick one. How about I just stick to AD and BC? So I'll say that AD is congruent to BC, and why in an isosceles trapezoid, the non-parallel sides are congruent. Okay, so now that establishes our angle side here. So I could say, statement 7, triangle ADE is congruent to triangle BCE by AAS. But now, how do we know that AEB, so AEB is here, how do we know that this is isosceles? Well, because these two triangles are the same, now we could say their corresponding parts are the same. So that would tell us here, if I use, let's say, I don't know, I guess I'll use green. So that would mean like this side here, AE, is congruent to BE because of corresponding parts of congruent triangles. So I could say for 8 that AE is congruent to BE because CPCTC. Okay, so now we have the two triangles are congruent, so their corresponding parts are going to be congruent. And then 9, the last statement here, how do we know triangle AEB is isosceles? Okay, so triangle AEB is isosceles, blah, blah, blah. Like, just copy it exactly word for word because two sides are congruent. Okay, so that takes care of the triangle proof. The 6-pointer. All right, very painful question to go through, but whatever. It's conquered. It's over. All right, and then there was question 36, the last question. And after that, we are done. For this one, we have this nice pool. And ultimately, first we want to find what is the depth of the pool at the deep end. So we have all this stuff like here's a pool. It's 35 feet long. It's 16 feet wide. It goes out like this, but then, excuse me, it starts to drop down like this. It slopes down to the deep end. All right, that's like standard in like most like community pools and stuff. There's a shallow and a deep end. Sorry, I've just been talking for a while. Gotta hydrate a little bit. So what we're gonna do, and wow, my voice is finally starting to give out too. Okay, is we want to find the depth of the pool at the deep end. So we want to know like ultimately like what is this? Okay, that's what we're looking for. So we know like this part is 4.5 like all across. So like if I draw some stuff in here, like this distance, actually I'm going to draw it over here, which will be helpful for later. Like this is 4.5 also. So you see it's like 4.5, like basically straight to the back until it starts to slope downwards here. Okay, so it's 4.5 and then it starts to drop. All right, like that's the idea. So let's see. What we want to find here is what is this drop? Okay, because that drop here, like if you follow this across, like this, you could see that this distance is going to be equal here. This is going to be the same distance as the red. And then whatever this green distance is here, oh, that was 4.5. Like this 4.5 is staying the same across. So 4.5, and this is 4.5. So our concern here is going to be like, hey, what's the value of this? Let's say I call that y. Okay, that's what I'm looking for. Well, what we could figure out here is that so far, I'm going to highlight this stuff here. So I know I'm changing colors a lot because I really want people to get this. That the entire length is 35. So far we have 9 and we have 12.5. But this part is unaccounted for. So let me just take a look here. So this part, let me change colors. Here is unaccounted for. So like what's that distance? And that we could just use a calculator. I could do the subtraction in my head, but like why suffer here? Why suffer here? We have 35 is the whole distance, and we're just going to subtract. We have 9 plus 12.5. Okay, so 9 plus 12.5. So I'm going to like pause it after this part. So 13.5. Just to make sure people are understanding what's going on. Is everyone okay up to this point? Is my hope. That once we find this piece is 13.5 feet, you could even check that 9 plus 13.5 plus 12.5 is equal to 35. Okay, we need to know that piece because in order to find out what y is, like now you see we have this. So we've got a right angle here. We've got 13.5. This is 16.5 degrees, and we're looking for y. That we know the opposite. I'm sorry, we're looking for the opposite, and we know the adjacent. So now we could say tangent of 16.5 degrees equals y over 13.5. And now call this over 1, and you could just cross multiply. Y equals 13. Let me make that neater. 13.5. Let me try that one more time. Times tangent of 16.5 degrees. And the rest is like just type this in the calculator. So I'm just going to do that now. 13.5 times tangent of 16.5. And don't miss. Make sure you write 0.5. And that's going to give you, this would round actually to 4 feet because they said round to the nearest tenth of a foot. So we're just going to round this to 4. So this would be y equals 4 like this. So this would be 4 feet like this. So then what is the depth at the deep end? We would say the depth, at the deep end equals, I would have 4 plus 4.5. Make that neater. It's like the end of the night, so I'm like starting to fall off here a little bit. So this is equal to 8.5 feet. All right, which is reasonable. Okay, that's a reasonable deep end. 8.5 feet. Okay, cool. So yeah, this one, just be careful. There's a quote from Abraham Lincoln: give me 5 hours to chop down a tree, I'm going to spend 3 hours sharpening the axe. And that's so true here. You really just have to think about what they gave you and what you're looking for. So the depth is that vertical distance. So far we had 4.5. We had to solve for this based on the slope here, that this sloped downwards by 16.5 degrees. So the vertical drop was 4 feet. Okay, cool. 13.5. How did I get that? The entire distance is 35. So this piece, I did 35 minus, you see so far we had 9 plus 12.5. So we have 9 plus 12.5, but whatever that mystery distance is here has to total up to 35. And that gave us 13.5. Okay, so that's where that came from. Okay, cool. Yeah, I subtracted 9 and the 12.5 because the entire thing is 35. You see, like if I went like basically across the top like this would also be 35. All right, so this one is like very visual, like it's definitely very abstract. Now this next part, find the volume. This part is going to be like definitely a bit painful. All right, so stay with me. We're going to do this with 4 shapes. Okay, we're going to do, I'll color code them. We're going to do this rectangular prism. So this, so we have this one that I'm highlighting in green. Okay, and then we're going to have, this one is the trickiest. Okay, so be careful here. Then we're going to do this rectangular prism that I'm highlighting in purple. Okay, so we're doing this in purple. Okay, so that's this piece is the one we're doing after. This is the trickiest one. And then after that, we're going to do this triangular prism underneath. Okay, so this is like kind of like almost like a wedge of cheese. Okay, so this triangular prism here is probably the trickiest one to find, but it's not terrible. All right, and then last but not least, we find the area of like this last rectangular prism. So here. All right, so that's what we're finding. So the volume equals, we're going to do 4.5 times 9 times 16. So I'm going to put that part in green. So you see, this is just like length with height. So it's 4.5 times 9 times 16. Plus, purple is another rectangular prism, so still not so bad. Okay, so for this one, and I am like butchering this a little bit. Let me just fix this. Okay, so for the stuff in purple, now remember we found like this distance, I'll rewrite it in purple, was 13.5. So 13.5, the height is still, well, this part is 4.5, and this is 16 going this way. Okay, so this is 16. So we're going to have 13.5 times 4.5 times 16. So 13.5 times 4.5 times 16. Plus, this is the tricky one in orange. Okay, the triangular prism. So it's Cavalieri's principle, the area of the base times the height. And the base here is this right triangle. So you're going to have 1/2 y we found was equal to 4. So this distance here was 4 once we found it, times 13.5 times how far back does this go? It's still going back 16 feet this way. Okay, that's the width of the pool. Plus, finally, the last part. All right, if we talk about the last part here, and let's see, we'll write this part here in black. This part here is 12.5. The height, we found the depth in the deep end was 8.5, and this distance is still 16. Okay, so it's like 16 by 8.5 by 12.5 is once we're in the deep end. So 16 times 8.5 times, don't get old, 12.5. Wow. All right, that was quite painful. Okay, so the volume equals, type this in. I promise you, you will get 3752 cubic feet. Okay. I mean, just for the sake of it, whatever, I'll just type this in just so we could be sure. But we got 4.5 times 9 times 16 plus we've got 13.5 times 4.5 times 16 plus 1/2, which is 0.5, times 4 times 13.5. Wow, this is quite painful. Times 16. Please don't make a typo. Don't make a typo. Plus 16 times 8.5 times 12.5. 3752. Okay, cool. So that would be it. All right, and then one last part. Okay, a garden hose is used to fill the pool. Of course, they had to sprinkle this in. All right, so a garden hose is used to fill the pool. Water comes out of the hose at a rate. So here's the rate. It's filling the pool at a rate of 10.5 gallons per minute. Okay, how much time? This is the actual question. How much time to the nearest hour will it take the pool to fill 6 inches from the top? Wow. All right, so this is mean. This is a very mean question. So let me scroll to it. I'm going to get a fresh pool because we destroyed that last one. All right, just so you could see here. So this is rather mean. But here's the pool all over again. So the concept for this one is what we're looking for is we already know the volume was 3752. So just remember it before, 3752. And it was cubic feet. Okay? But what we're doing is we're filling it 6 inches from the top. Just know 6 inches is 0.5 feet. Okay? So you see how like this all around, we're going to like leave space. This is not drawn to scale, but we're going to leave space like this. Okay, so the volume that we don't need is this amount that I'm trimming off the top here. So you see we're leaving half a foot. I guess that makes sense because they don't want it to fill to the very, very top because that would be insane. So this is 16 by 35 by 0.5. See, that's 0.5 feet. Okay, so basically the volume like to be filled is what I'm going to find is equal to the total volume 3752. Okay, and I'm going to leave space here minus, we're doing length times width times height. So we're going to do 16 times 35 times 0.5. So we're subtracting out the volume we don't need. We want to leave 6 inches of space, or half a foot of space. So we're subtracting that out, and that's how many cubic feet that we need to fill. So this, once again, you need a calculator. So 3752 minus, and we're doing half a foot times 16 times 35. Okay? Which is 3472. 3472. So 3472 cubic feet. That's how much we have to fill. So what we have to do with this, they told us the rate is in gallons per minute. So what they told us, this is pretty useful. 1 cubic foot is 7.48 gallons. So what we could do, like the volume needed in gallons, we could say is 3472 cubic feet. And this is an algebra skill. You're going to multiply this by 7.48 gallons over 1 cubic foot. Because think about it. Every cubic foot, you have this many gallons. So for this many cubic feet, we have to multiply, and the cubic feet cancel. And if you multiply that out, this should work out to, whatever, I'll just show it in the calculator. So times 7.48. 25,970.56. Okay, so we've got 25,970.56 gallons. But now, remember, we're answering how much time does it take to the nearest hour. And this is where the rate comes in now. That the hose fills it up 10.5 gallons per minute. Okay, so you have to think about this very carefully here. If you do 10.5 gallons for every 1 minute, how many minutes is it going to take you to do this many gallons? And there's a few ways you could do it. You could even set up a proportion here. Like you could say 25,970.56 gallons over X minutes equals 10.5 gallons over 1 minute and cross multiply. Like that works. So why not? I'll just do it that way. 25,970.56 gallons in X minutes. So that's what we're looking for. How many minutes? Is equal to, the rate is 10.5 gallons for every 1 minute. Okay, so this would just give us in numbers, we'd have x times 10.5, so 10.5x equals that number times 1 is that number. I just don't feel like saying that number anymore. So divide by 10.5 on both sides. And this will tell you x is equal to, and we just have to divide that number by 10.5. So divide by 10.5 is 2473, and then we have 0.38667. Okay, so 2473, and don't get old, 0.38667. 0.38667, like this. All right, so that tells us so far we have and I just made a typo. We have 2473.38667 minutes. But how many hours is that? We would multiply by, there's 1 hour for every 60 minutes. So just divide that by 60. Okay, and the units cancel out here. Let me just get rid of that stray dot. So now, finally, just divide by 60. And don't divide by 30, divide by 60. And to the nearest hour, that's going to be 41 hours, 41.223. So this is, 41.223 hours. But to the nearest hour, just making sure I didn't round incorrectly, 41 hours is our answer. Okay, there's a lot of back and forth. This is a really painful question here. But yeah. Oh, wow, the chat. I hadn't read it in a while, but it was quite active. Yeah, but that's what's going on. I'm sorry. I'm doing my best to make it as easy as I could. But that's if you want to get 100. You got to be able to do everything I just did. Okay? You don't need to get 100 to move to the next level, so don't worry. But let's see. How are we on time? We are, 10 minutes till 3 hours. So we did it. All right, we did it. So for this last part here, I just want to, look at the chat, say good luck to everybody. If you have not subscribed yet, please consider subscribing. If this helped you in any way, shape, or form, I really do appreciate the support. It does help me grow the channel. And if I'm able to grow the channel, I'm able to reach more people here. Today was really just an awesome day all around for this channel. I can't thank you all enough for making this possible. It really does blow my mind when I look at the numbers here, seeing that over 5,200 people stopped by the live stream here. I'm just truly grateful to all of you for helping me out. So thank you. Good luck. And look, if you're nervous, oh no, I'm nervous, I'm going to fail. I know some people are saying they're going to cry, they're upset, but just hang in there. Okay, do your best to study as much as you can before, get a good night's sleep. And then tomorrow, you're just going to show up, you put your best math down on the paper and do the best you can. All right, so thank you for stopping by and have a good night.